Astronomers just spotted something that should not be happening. Right now, 7 comets are streaking sunward, not spread across years or seasons, but converging within days of one another in October 2025. In the entire record of human observation, nothing of this scale has clustered like this. And as if that coincidence weren't strange enough, a true interstellar visitor, 3I Atlas, is threading its way through the same narrow window. The odds of both events lining up by chance are vanishingly small, unless something is hurting them. Tonight, we begin by seeing what the data actually says, and then we let the questions come. Are improved telescopes simply catching objects we always missed? Is the sun, at the peak of its 11-year tantrum, making ordinary arrivals look extraordinary? Or do these patterns point to a mechanism we don't yet understand? A force, a region of disturbed space, or the ghost of a gravitational encounter long ago? We will follow evidence first, curiosity second, and the worst fears only when they demand consideration. It starts with how things are found. Modern sky surveys, robotic telescopes scanning the heavens night after night, have rewritten the census of small bodies. Cameras that once photographed a handful of faint smudges now catalog thousands of moving points every month. Automated pipelines flag anything that shifts against the star field. Volunteers and professionals verify trajectories. Orbits are computed within days. The result is a richer inventory of the outer solar system than any previous generation could imagine. That matters because detection bias matters. You can't claim a surge of arrivals unless you account for the instrument that notices them. But detection isn't destiny. A comet's visibility depends on its intrinsic brightness, size, composition, and how much volatile material it sheds near the sun. A tiny rock coated in dust remains invisible until sunlight strips the insulating crust away and volatile ices begin to vaporize. Brightness predictions are notoriously fickle. Comets can flare unexpectedly or sputter and fade. Still, when veteran observers, people who have watched comets for decades, react with surprise, it's worth listening. The pattern in 2025 isn't just more faint finds. It's multiple objects brightening into the range of modest telescopes and binoculars within weeks of each other. That is unusual. Timing collides with physics at solar maximum. Our star runs an 11-year cycle of magnetic mischief. Sunspots, flares, and coronal mass ejections paint the heliosphere with energetic storms. During these peaks, comet tails react like flags in a gale. Ion tails can kink, disconnect, and flare. Dust tails balloon under changing radiation pressure. Solar weather can make many comets more photogenic than they would be in a quieter year. But it cannot manufacture comets from nothing. The sun's mood affects appearance, not the deep orbital roots set millions of years ago. So why do 7 objects arrive together? Statistical clustering happens. Flip enough coins and long runs appear. But clustering invites explanation. If these comets shared source regions, similar orbital signatures, or synchronous perturbations beyond expected variance, physics would want an answer. Gravity is the obvious suspect. Massive bodies shepherd smaller ones all the time. Jupiter corrals Trojan asteroids and scatters comets into short-period orbits. Yet, gravitational shepherding on the scale needed here would leave fingerprints in orbital elements. We can read those fingerprints. Early analyses show diversity. The 7 trace back to different parts of the outer reservoir. That diversity raises the evidentiary bar for any single gravitational culprit. Enter 3I Atlas, a hyperbolic interstellar stranger carrying the chemical memory of another star and moving fast enough to escape our system forever. Interstellar objects are banal in concept, but profound in consequence. They are physical letters from other stellar nurseries. 3I Atlas is not massive enough to tug multiple comets into synchronized arrivals by classical gravity. Its trajectory is too fast, its mass too small. But its mere presence complicates the narrative. Could it be a signal, a marker of a broader dynamical disturbance in the outskirts of the Sun's domain? Could its passage correlate with a transient enhancement in comet delivery from distant reservoirs? Or is it a cosmic red herring, arriving in a year when survey sensitivity and solar theatrics combine to produce a story our pattern-seeking minds insist on reading as meaningful? Tonight, we will not leap to drama. We will lay out mechanisms, describe what to look for at perihelion, and sketch how the scientific method separates plausible from fanciful. We will watch how tails respond to coronal storms, how light curves evolve, and whether orbital perturbations whisper of common origin. We will also watch the human reactions: wonder, alarm, conspiracy. All of these are part of the story. If you want the nightly updates as new measurements come in, the spectra, the light curves, the node crossings, subscribe and follow the observation logs. For now, step close. The sky is setting a rare scene, and we'll move through it one observation at a time. To understand why this year has astronomers whispering in late-night conference calls and scribbling notes in margins they usually keep pristine, we have to step back. Step far back, past the headlines and the chatter, to the mechanics of how we even know what is happening in the skies above us. Because without the technology, without the relentless surveys scanning every arc of the heavens, these comets would have remained ghosts. Silent travelers never entered into human memory. The revolution began quietly. In Hawaii, Chile, and the deserts of Arizona, wide-field telescopes were wired with digital eyes. Each night, they sweep across enormous slices of sky, capturing millions of dots. Sophisticated algorithms comb through the images, searching for the subtle motion of one star that doesn't stay put. 99% of those dots are noise, but that 1%, the moving point of light, becomes the birth certificate of a new celestial object. Within days, orbit calculations are run. Within weeks, predictions emerge about where the object will travel, how close it will pass, and how bright it might flare. A century ago, such discoveries belonged to a handful of dedicated amateurs who spent sleepless nights with sketch pads beside their telescopes. Today, it's automated, relentless, industrial. The flood of data has given us a sky richer and stranger than our ancestors could have imagined, which makes this clustering all the more unsettling. In a data stream that should be random, why do 7 bright comets stack together in 2025 as if choreographed? Brightness is the key. A comet is not born bright. Its nucleus, typically just a frozen chunk of rock and ice, maybe a few kilometers wide, is invisible against the cosmic backdrop. Only when sunlight strikes and begins vaporizing those buried ices does a coma expand, glowing with reflected light and the bluish shimmer of ionized gas. Most comets never reach the naked eye. They remain faint smudges, known only to observers with patience and large optics. But every so often, one surprises us. It flares. It disintegrates in a dazzling show. Or it grows brighter than the most optimistic models ever dared suggest. That is what has astronomers shifting in their seats. not faint objects scattered across years of discovery, but 7 that are predicted to cross into visibility within weeks of each other. The normal rhythm of comet discovery is slow, almost reassuring. 1 or 2 per year worth watching, many others slipping by unnoticed. 7 is more than anomaly. It is rupture. Some point to coincidence. Clustering happens in random systems. Flip a coin enough times, and improbable streaks emerge. 10 heads in a row, followed by long deserts of tails. Statistically inevitable. But humans are not built for statistical comfort. We are pattern-seeking animals. Our ancestors survived by seeing shapes in the dark and warnings in the wind. Today, the same brain circuitry interprets cometary schedules as if they were calendars written for us. And when coincidences stack, we search for the hand stacking them. But there is another layer to this year's cosmic drama: the Sun. In 2025, our star reaches the peak of its activity cycle. Solar maximum means more flares, more charged particles, more turbulent solar wind. Comet tails are whips in that wind. They lengthen, twist, and even snap away when streams of plasma collide with them. During maximum, tails are not subtle. They blaze like banners, which means comets that might otherwise slip past quietly can become spectacular. The year's clustering is not just numerical. It is visual, dramatic, unforgettable. So perhaps the explanation is as simple as physics plus perception. More comets were detected because surveys are better. They look brighter because the sun is angrier. And we, ever eager for narrative, find a story where none was written. Yet, beneath that rational surface, an unease lingers, because for every neat explanation, there is a whisper of something more. Gravity does not play dice. If orbits align more tightly than chance should allow, we must ask why. If comets are not siblings from the same region of the Oort cloud, if they have been nudged into new paths by something invisible, then where is the culprit? Jupiter has long been our cosmic shepherd, scattering and corralling small bodies. Its fingerprints are everywhere in the architecture of the solar system. But these comets show no clean link to the gas giant's usual domains. Their origins diverge, their histories do not match. And so the whisper grows louder. What else could be out there, bending the fabric just enough to drive 7 icy bodies into the inner system together? This is where the narrative teeters between science and speculation. On one side, improved surveys, solar activity, statistical clustering. On the other, the suspicion that something larger, something hidden, is pulling the strings. In that gap, between what we know and what we fear, 3I Atlas enters the stage. When scientists speak of coincidences in astronomy, they usually do so with a shrug. The sky is vast, the number of small icy bodies beyond counting, and so every improbable pattern eventually emerges if you wait long enough. Yet, there are limits to patience. When 7 comets converge within weeks of each other in 2025, and when an interstellar visitor times its passage through the same window, the line between coincidence and correlation becomes harder to ignore. To push further, we have to examine the physics of shepherding. In celestial mechanics, shepherding describes the way large bodies control the paths of smaller ones. Saturn's rings hold sharp edges because tiny shepherd moons nudge particles back into line. In the Kuiper Belt, dwarf planets like Pluto and Haumea corral populations of icy fragments into resonances that can last for millions of years. In our own solar system, Jupiter is the most obvious shepherd. Its gravity is so powerful, it diverts comets into new orbits, captures some into short-period loops, and ejects others entirely. The fingerprints of Jupiter's interference are written across our history. The Shoemaker-Levy 9 collision in 1994, where fragments slammed into the gas giant's atmosphere in a cosmic fireworks show, was a direct consequence of shepherding gone extreme. Jupiter had captured the comet, torn it apart with tidal forces, and then delivered the pieces into its own face. Observers on Earth watched the scars bloom across the planet's surface, an unmistakable reminder that giants dictate the fates of smaller wanderers. So naturally, the first question in 2025 was whether Jupiter had orchestrated this apparent parade. Early orbital solutions were compared, data plotted, and the result? Diversity, not unity. The 7 comets do not share a common resonant history. They hail from scattered regions of the outer Oort cloud, their trajectories shaped by billions of years of random encounters, not by a single guiding hand. That makes the Jupiter hypothesis unlikely. What about a hidden planet, the so-called Planet 9? For a decade, speculation has simmered about a massive, unseen world lurking in the distant reaches of our system, perhaps 10 times Earth's mass, tugging on objects far beyond Neptune. Could such a body explain the clustering? Perhaps in principle, but not in practice. Planet 9, if it exists, would operate on time scales of tens of thousands of years. Its gravitational reach would sculpt broad alignments, not sudden synchronized arrivals in a single year. To invoke it here stretches plausibility past the breaking point. Electromagnetic forces? The idea surfaces in fringe discussions. Perhaps magnetic fields or solar interactions create patterns we cannot yet map. But again, the physics resists. Electromagnetism is strong at small scales, within plasmas, within cometary tails, but it does not act across millions of kilometers to synchronize the entry of entire nuclei from deep space. What looks like coordination is more likely emergent chance dressed in our need for order. And yet, the question persists. Why now? Why 2025? If the answer lies in probability alone, it is a rare and fragile cluster. If not, then what remains unseen in our models? Into this gap steps 3I Atlas. Designated as the third confirmed interstellar object to cross into our solar system, after Oumuamua in 2017 and 2I Borisov in 2019, it carries the intrigue of the unknown. Unlike comets bound by the sun's long leash, interstellar objects arrive from elsewhere, bearing the chemical memory of alien nurseries. Their paths are hyperbolic, their velocities so great they cannot be captured. They come, they skim, they leave, never to return. 3I Atlas is different, not only because of its timing, but also because of its properties. Early spectra hint at unusual chemical ratios, not entirely outside expectation, but distinct from the majority of comets cataloged in our system. Its trajectory threads uncomfortably close to the time frame of the 7 native comets. And while gravity alone cannot link them, the coincidence sparks suspicion. Could this object be the signpost of a larger process? Some scientists propose that 3I Atlas might simply be the messenger, not the cause. Its arrival could indicate a broader flux of material through our galactic neighborhood. Perhaps our system is passing through a dense region of interstellar debris, and the simultaneous influx of comets is merely the local expression of that crossing. Others argue the opposite, that our detection bias has finally reached the threshold where such patterns become visible, and 2025 is only the first year where technology, timing, and solar activity make the coincidence obvious. For the public, nuance often collapses into drama. Articles appear with headlines about cosmic conspiracies, hidden shepherds, or even alien signals. The leap from data to mythology is quick, and once seeded, hard to uproot. But within the scientific community, the tone is quieter. The clustering may not demand exotic explanations. Still, the arrival of an interstellar traveler during this same window is more than enough to justify caution, to justify attention. What happens next depends on observation. As 3I Atlas approaches perihelion, its behavior will tell us more than speculation ever could. Will it fragment under solar heat? Will its coma bloom with exotic chemistry unseen in local comets? Or will it pass quietly? A reminder that the universe writes coincidences we cannot help but read as stories. And what of the 7? Each will trace its fiery arc across the night, visible to amateur observers and professional arrays alike. Together, they form a chorus, unlikely, perhaps unrepeatable, that sets the stage for deeper questions about randomness, order, and the forces we have yet to map. When 3I Atlas first appeared in the raw data stream, it was a faint smear of light, a pixel moving just enough to betray its foreign origin. But astronomers have learned to spot strangeness quickly. Its velocity was the giveaway, far too fast to be bound by the sun's gravity. The moment the orbit was fit, the classification followed. Another interstellar visitor, the third of its kind ever confirmed. Oumuamua, the first, had startled us in 2017. It tumbled through on a bizarre trajectory, reflecting light in ways no one had anticipated, sparking speculation from frozen shard to alien probe. Then came 2I Borisov in 2019, much more ordinary, a comet-like traveler with a tail of cyanide gas, proof that our galaxy is filled with frozen wanderers born of other stars. And now, years later, 3I Atlas. 3 objects in less than a decade after billions of years of silence. Was this a true increase, or simply better eyes on the sky? For the scientific method, such questions demand restraint. But for human imagination, they demand wonder. And the timing of Atlas only fed that hunger. As the 7 comets fell sunward, here came another, not from the Oort cloud, but from the deep dark between the stars. Coincidence or choreography? That was the question whispered in observatories from Chile to Hawaii. Spectroscopy offered the first real glimpse. When starlight filters through a comet's coma, it carries fingerprints, absorption lines from the gases evaporating into space. Most comets show the same signatures: water vapor, carbon monoxide, cyanide, dust. 3I Atlas showed those too, but in odd ratios. Carbon chains stronger than expected, oxygen weaker. Not alien in the science fiction sense, but alien in the geological sense. Different nursery, different chemistry. In those ratios lies a history. The conditions of the star system where it formed, the radiation that bathed it, the collisions that shaped it. To hold such an object in view is to hold a sample from another sun. Its nucleus appeared darker than average, reflecting little sunlight as though wrapped in a skin of ancient carbonized dust. And yet, when heated, it released more gas than predicted, a sign that volatile ices lay hidden beneath. Early estimates placed its size at a few hundred meters, large enough to endure perihelion, small enough to remain elusive. Unlike Oumuamua, it was not cigar-shaped or wafer-thin, at least not in any way the data could confirm. But it carried the same aura of mystery, a messenger that refused to explain itself fully. What unsettled astronomers was not what it was, but when it arrived. To study 7 comets is already a gift. To study them in the same year as an interstellar object feels like overabundance, as though nature had staged a grand experiment. And once again, pattern-seeking minds rushed to fill the gap. Could Atlas have disturbed the Oort cloud during its entry, nudging long-dormant comets into falling sunward? On paper, the answer was no. Its mass was too small, its time too short. But the suspicion lingered in the spaces between equations. There was another possibility, more subtle, more unnerving. Perhaps 3I Atlas was not the cause but the symptom of a larger dynamical stream, a river of material flowing unseen across the galaxy. Our solar system may simply be drifting through it, sweeping up both interstellar strays and triggering fresh arrivals from our own distant reservoirs. If true, this would mean the cluster was not random at all, but a byproduct of galactic motion, a resonance between local and interstellar debris. For now, there is no way to prove this. The data are sparse, the models incomplete, but the speculation itself carries power. It reminds us that the sun is not stationary, that our system drifts around the Milky Way at hundreds of kilometers per second, plowing through clouds of gas, dust, and perhaps comets unseen. What we call coincidence may simply be perspective, the brief flare of sparks when 2 rivers meet. Public interest surged as the news spread. Social media transformed 3I Atlas into a symbol, half scientific marvel, half omen. Memes called it the Shepherd. Articles speculated about its role as a cosmic trigger. Most scientists avoided such language, preferring caution, but the momentum of narrative is hard to stop. Where the public sees signs, science sees data. Still, one truth binds both. We are witnessing something rare, something fragile, something worth recording in detail. And so, telescopes track Atlas every night it can be seen. Infrared instruments measure its thermal glow. Spectrographs parse its chemistry. The cometary cluster is monitored alongside, each nucleus cataloged, each tail mapped. Together, they create a dataset unique in history. And waiting behind the numbers is the question no calculation can silence. Is this alignment the cosmic dice at work? Or is it the shadow of a force we have yet to chart? The human mind is brilliant at connecting dots, but it is also unreliable. Throughout history, comets have been read not as frozen fragments of ice, but as omens. In medieval chronicles, a blazing tail meant plague, war, or the fall of kings. Even in the 20th century, tabloids framed every bright visitor as a harbinger. We may laugh at those interpretations now, yet the same instinct persists. When 7 comets and an interstellar object align in time, even the most disciplined scientists feel the pull of narrative. But science asks us to separate feeling from evidence. So, what does the evidence say about this clustering? The orbits, when plotted carefully, do not converge on a single parent. They scatter across inclination, perihelion distance, and eccentricity. In plain language, these comets are not siblings. They are not fragments of one broken giant, released together like shards from a shattered bottle. Each has its own history, its own origin in the distant Oort cloud. That makes the pattern harder to explain, and paradoxically, more compelling to the imagination. The Oort cloud itself is a place we know only by inference. Stretching perhaps a light year from the sun, it is a spherical reservoir of trillions of icy bodies, leftovers from the birth of the solar system. Too distant to observe directly, Its existence is betrayed only when one of its residents is nudged inward by gravitational whispers. Passing stars, galactic tides, or molecular clouds drifting through the Milky Way, the comets we see are the messengers of that invisible sea. Each one that falls sunward is a sample, a clue to the architecture of the distant dark. Statistical models predict that such nudges should produce a steady trickle, not a synchronized flood. The sudden clustering in 2025 stretches those models, not beyond breaking, but far enough to make us ask, are the inputs incomplete? Did we underestimate the frequency of stellar encounters? Did we miss a passing interstellar cloud whose gravity brushed against the cloud's edge thousands of years ago, now bearing fruit in a cascade of arrivals? The truth is that orbital mechanics is deterministic in principle but chaotic in practice. Tiny changes in velocity, billions of kilometers away, compound into dramatic differences over millennia. What we perceive as coordination may be the echo of long-past perturbations, amplified by time. 7 arrivals in 1 year may be nothing more than the roll of cosmic dice. But if the dice are weighted by galactic tides, then chance and necessity blur together. Meanwhile, 3I Atlas refuses to be ignored. Its path is independent of the Oort cloud, its velocity too high, its chemistry too foreign. And yet, its appearance in the same calendar year keeps dragging it back into the conversation. The public leaps to the most dramatic version: alien coordination, hidden forces. Scientists resist, but even they cannot fully dismiss the coincidence. At conferences, slides appear with cautious titles: temporal correlation of interstellar and native cometary events, a phrase that says everything and nothing at once. As observations accumulate, Atlas shows stability. No sudden breaks, no dramatic outbursts, at least not yet. Its coma expands modestly as it nears the sun, revealing the usual volatiles, but in unusual balance. The carbon-rich chemistry hints at a nursery different from ours, perhaps colder, perhaps dustier, perhaps shaped by a different kind of star. To study it is to study the galaxy itself. Each ratio of gases is a fingerprint from another stellar system, a whisper across interstellar space. Public fascination grows with every update. Amateur astronomers train backyard telescopes on the cluster. Forums fill with grainy images of faint smudges. News outlets pick up the story, often with less restraint. 7 harbingers and a stranger, one headline reads. Scientists roll their eyes, but secretly, some appreciate the attention. Funding follows fascination, and fascination follows spectacle. If comets can spark curiosity about the universe, perhaps their timing is a gift. Still, the unease remains. What is coincidence? What is causation? At what point does probability stop being an explanation and start being a placeholder for ignorance? These questions hang in the air like tales themselves, luminous and unresolved. And beneath them, the deeper wonder. We are alive at a moment when such a spectacle unfolds overhead. A cluster of icy wanderers and a messenger from another star, together in the same sky, within the reach of our instruments and our imagination. It will not last. In months, the comets will fade back into darkness. Atlas will speed away into interstellar night, and the sky will return to its quiet trickle. But for now, in 2025, we are witnesses, and perhaps that is the real story. Not omens, not conspiracies, but the rare privilege of seeing cosmic randomness converge into a moment that feels like meaning. If the Oort cloud is the deep reservoir of comets, then the sun is the sculptor of their final performance. As these icy wanderers fall inward, what we see is not the nucleus itself, but the interplay between frozen material and solar energy. Every flare, every twist of a tail, every glowing coma is a dialogue with the star that birthed our world. And in 2025, that dialogue is louder than usual because the sun is restless. Solar maximum is not just an astronomical footnote. It is the storm season of our star. Roughly every 11 years, magnetic fields on the sun tangle, break, and reconnect in violent arcs of plasma. Sunspots bloom like bruises across its surface. Flares erupt with energies equivalent to billions of nuclear bombs. Coronal mass ejections hurl clouds of charged particles into interplanetary space, expanding at speeds that dwarf any earthly storm. For comets, this cycle is transformative. Their ion tails, those ghostly blue streaks of electrically charged gas, respond immediately to changes in the solar wind. When a coronal mass ejection sweeps through, a tail can snap off and reform in hours, a luminous ribbon cut and retied by invisible forces. Dust tails, made of heavier particles pushed by sunlight, broaden under the enhanced radiation pressure. At solar maximum, even modest comets look dramatic, their features exaggerated by the star's volatility. This helps explain why 2025 feels so spectacular. The comets themselves are not larger than those of previous years, but they are illuminated by an angrier sun. Their tails whip and flare in synchrony with solar storms, making them appear more vibrant, more alive. And when 7 of them are on stage together, the result is a sky alive with banners, each one tracing the solar wind's invisible flow. Yet, there is irony here. The same solar activity that makes comets spectacular also makes observing them difficult. Charged particles disrupt radio communications, interfere with spacecraft instruments, and scatter signals. Ground-based observatories must contend with geomagnetic disturbances. Satellites, designed to study comets, risk temporary blindness as solar storms overwhelm their sensors. The cosmos offers a feast, but it comes with static on the line. Scientists exploit this volatility as much as they suffer from it. By watching how each comet's tail responds to solar events, they can map the flow of plasma through interplanetary space. Comets become probes, their luminous features tracing invisible currents. In 2025, with multiple comets available at once, researchers speak of a natural laboratory, a way to compare how different bodies respond to the same solar environment. Never before has such an opportunity presented itself, and likely never again in our lifetimes. Meanwhile, 3I Atlas complicates the picture. Its chemistry is different, its history foreign, and its behavior under solar maximum could reveal not just how comets act, but how alien comets act. Will its tail snap under a coronal mass ejection the same way? Will its volatile ices respond to solar heat in predictable fashion? Or will it reveal processes unfamiliar, signatures we have never seen before? Every telescope trained on it waits for those answers. Outside the scientific community, the spectacle fuels imagination. Social networks fill with images of glowing streaks across the sky, captured on phones and amateur cameras. To many, it feels like a cosmic performance staged for human eyes. Conspiracy forums speak of coordination, of hidden messages, of the Shepherd Comet. But step away from the noise, and the truth is simpler, more profound. We are watching the sun converse with ice from the edges of time. The comets will not last. Their ices will vaporize, their tails will fade, and their nuclei will retreat back into darkness. or disintegrate entirely. But while they last, they are mirrors of the sun's mood, painting the sky with solar weather made visible. And in 2025, at the height of solar maximum, those mirrors are dazzling. Astronomy thrives on such fleeting windows. Most years, a single bright comet is a gift. In this year, with 7 and an interstellar stranger besides, the gift borders on excess. For scientists, it is a data set of dreams. For the rest of us, it is a reminder that the universe is not static. It breathes, it changes, and sometimes, by sheer chance, it aligns in ways that make us stop, look up, and wonder if there is more at play than physics alone. When people imagine comets, they often picture icy cannonballs diving straight toward the sun. But the truth is subtler. These are not projectiles, but survivors of billions of years, each carrying a unique record of conditions from the dawn of the solar system. To understand why their sudden clustering is so strange, we must first recall how rare visible comets usually are. Most comets never achieve brightness beyond the reach of powerful telescopes. In a typical year, perhaps 1 or 2 might grace the sky with enough brilliance for the unaided eye. For professional astronomers, the majority remain faint smudges, curiosities cataloged and filed away. The appearance of 7 visible comets in 2025 breaks this rhythm, forcing a comparison not just to statistical models, but to the long arc of human observation. Records from Chinese court astronomers, Babylonian scribes, and medieval European monks show comets arriving sporadically, sometimes in clusters, but never in numbers like these, within such a short span. To frame it properly, think of chance. Imagine throwing dice across a table for centuries. Most rolls yield unremarkable results, scattered numbers blending into noise. But then, one night, the dice land 6 after 6 after 6, as though guided by an unseen hand. Statistically possible, yes, but unlikely enough to make you pause. That pause is where astronomy now finds itself. Caught between probability and suspicion, between the mathematics of randomness and the intuition that nature may be hinting at something more. Some researchers compare the event to meteor showers. Every year, Earth plows through dust trails left by comets, producing streaks of light across the sky. To the casual observer, meteor showers look like orchestrated performances. In reality, they are the result of orbital mechanics, predictable intersections of Earth's path with streams of debris. Could the 2025 cluster of comets be a similar kind of resonance? A temporary alignment caused by long-forgotten perturbations? If so, the explanation might be simpler than it appears. Not conspiracy, not coordination, but the inevitable geometry of moving bodies. Yet others point out that comets are not dust trails. They are singular bodies, massive compared to the particles of meteor showers, each with its own orbital signature. To bring 7 of them inward at once requires either immense coincidence or a trigger we have not yet identified. The debate sharpens. Is this a statistical fluke amplified by solar maximum? Or is there something else unseen, tugging at the edges of our system? This is where 3i Atlas returns to the stage like an uninvited guest. Its trajectory is hyperbolic, meaning it is not bound to the sun. It will pass through and vanish forever. It cannot be the shepherd, at least not by gravity alone, but its mere presence adds weight to the sense of timing. An interstellar object arriving during the same year as the greatest cometary display in recorded history feels scripted, even when the physics insists otherwise. And in science, feelings can be dangerous. They tempt us to shape data around narratives instead of shaping narratives around data. Nevertheless, scientists have learned that even coincidences deserve study. The clustering becomes a natural experiment. What can simultaneous comet arrivals teach us about solar wind, about tail formation, about chemical diversity? What can an interstellar traveler reveal when placed in the same frame as native objects? In effect, 2025 becomes a laboratory written across the sky. The first months of observation bring surprises. 2 of the 7 comets fragment, shedding smaller bodies that create their own miniature tails. Another brightens faster than predicted, suggesting a pocket of volatile ices closer to the surface than models expected. One remains stubbornly faint, defying forecasts, an echo of countless comets that fade instead of flare. Each one tells a story not just of itself, but of the system that birthed it. And alongside them, 3I Atlas whispers its alien tale. Its coma reflects sunlight differently, with a darker hue. Its gases trace a chemistry unusual enough to provoke debate, but familiar enough to prove it is still natural, not artificial. Theories abound. Perhaps it formed in a system richer in carbon, or colder, or older. Every spectrum is a puzzle piece in a picture we may never complete. For now, the sky holds more questions than answers. And perhaps that is the essence of science. Not to silence wonder, but to sharpen it. To remind us that even when patterns may be random, the act of studying them brings us closer to truth. In 2025, the comets blaze not only in the heavens, but in our imaginations, forcing us to reconsider how much we know and how much remains hidden in the dark. When the comets of 2025 first appeared in the survey data, they were little more than moving points of light. To the untrained eye, nothing about them seemed remarkable. But as weeks passed and their orbits were refined, astronomers realized just how unusual this year was becoming. Each comet on its own would have been unexceptional, a minor entry in the endless catalog of icy wanderers. Together, however, they became something else, a chorus of anomalies. The clustering forces us to look at the architecture of the solar system itself. Our sun is not alone in shaping the fates of comets. The distant pull of passing stars, the tidal field of the Milky Way, and the gravitational nudges from giant planets all contribute to the slow, chaotic ballet of small bodies. Each perturbation is a whisper, almost imperceptible, until time amplifies it. A comet, nudged slightly inward tens of thousands of years ago, may only now be revealing itself, its path folded into the sudden convergence of 2025. If this explanation holds, then what we see is not coordination, but coincidence magnified across deep time. The comets share no common parentage, no single event that can be traced back in the recent past. Instead, they are survivors of ancient, unrelated perturbations, arriving together only because their journeys happened to synchronize in the present. Like ships departing from different ports centuries apart, now docking in the same harbor on the same day, they seem connected only because we are here to witness the meeting. Yet coincidence alone is rarely satisfying. Science demands models, predictions, and reproducibility. And here lies the difficulty. Clusters like this are rare by definition. They resist study because they may not recur in centuries. To scientists, this makes them both frustrating and precious. Every instrument must be trained on them, every data set archived, every observation maximized, because the chance will not come again. This is why the year has become an international collaboration on an unprecedented scale. Observatories across the globe share data nightly. Amateur astronomers upload their images to central databases where professionals analyze them for tail dynamics and outbursts. Space agencies divert spacecraft to observe the cluster, seizing the opportunity to test theories of solar-wind interaction. Even weather satellites are repurposed, their instruments measuring solar activity that sculpts the comet's luminous veils. And then, always, there is 3I Atlas. Its trajectory is not tied to our solar system's history. It comes from far beyond, carrying information about another star's nursery. Its timing is uncanny, but its physics is independent. For many astronomers, this is both relief and torment. Relief because it prevents the leap to unscientific conclusions. Torment because the coincidence remains impossible to ignore. As Atlas approaches perihelion, its behavior begins to diverge from expectation. Unlike the 7 native comets, it does not flare dramatically under solar heating. Its dark surface absorbs energy, but releases gas sparingly, suggesting a crust hardened by eons in interstellar space. Instead of a wide fan of dust, it trails a narrow, faint ribbon, less spectacle, more enigma. This restraint makes it harder to study, but also more intriguing. Why should an object rich in volatiles remain so stubbornly quiet? What processes hardened its surface? What history sculpted it before it ever entered our skies? Meanwhile, the 7 comets perform with the extravagance expected under solar maximum. Their tails twist and snap under the influence of coronal mass ejections. One displays a sudden outburst, its brightness increasing tenfold in hours. Another fragments, shedding icy shards that create their own miniature displays. For astronomers, these events are data treasures, opportunities to compare behavior across multiple bodies under the same solar conditions. Never before has the sky provided such a simultaneous laboratory. The juxtaposition is striking. On one side, the noisy, dramatic comets of our own system, flaring and fragmenting in response to the sun's moods. On the other, the quiet interstellar stranger, dark and restrained, refusing to play by the same rules. Together, they create a narrative that feels almost deliberate, though science insists it is not. A cosmic stage where local and foreign, noisy and silent, ordinary and extraordinary, share the same moment in time. For the public, that stage is irresistible. News outlets broadcast nightly images of glowing streaks across the sky. Social media hums with speculation, blending science with myth. Some claim the interstellar object is the conductor, guiding the comets like instruments in an orchestra. Others insist it is merely a coincidence magnified by human imagination. But in a sense, both are true. The physics is coincidence. The meaning is ours to assign. In the end, that may be the real power of 2025. Not that comets are coordinated by some hidden hand, but that we are here to see them together, to weave them into a story, and to let that story remind us of how small we are in a cosmos that never ceases to surprise. The story of comets is also the story of fragility. These are not solid worlds like planets or even rugged asteroids. They are porous, fragile conglomerates of ice and dust, so loosely bound that the term dirty snowball hardly does justice to their delicacy. When they approach the sun, heat and tidal forces test their cohesion. Many fail. They fragment, disintegrate, and vanish, leaving only ghostly debris trails behind. Already in 2025, 2 of the 7 comets have shown such fragility. Their nuclei cracked under stress, shedding fragments that briefly shone before fading into invisibility. To astronomers, this is not disappointment, but opportunity. Fragments expose interiors, revealing layers untouched for billions of years. Spectra captured in the hours after breakup display fresh signatures, gases that rarely reach the surface, ices that would otherwise remain locked away. Each disintegration is a window into primordial chemistry. For the public, though, breakups often feel anticlimactic. A comet expected to blaze across the sky fades instead into obscurity. Social media posts captured disappointment. It just vanished. But this too is part of the lesson. Comets are not performers obeying our schedules. They are fragile relics obeying physics, and their unpredictability is what makes them valuable. 3I Atlas, by contrast, has resisted drama. Its dark crust seems to insulate its core, releasing gases only sparingly. Observers expected outbursts as it neared perihelion, but instead it remained muted, almost aloof. Some speculate that its journey through interstellar space baked its surface into a hardened shell, sealing volatile layers beneath. If so, its quietness is itself a discovery, proof that interstellar comets may evolve differently, toughened by radiation and cosmic dust across millions of years of solitary travel. This difference between native and interstellar bodies sharpens the contrast. The 7 local comets are fragile and flamboyant, their tails whipped into glowing arcs by solar storms. The interstellar traveler is subdued, enigmatic, its presence less spectacle and more riddle. Together, they highlight the variety of pathways icy bodies can take and how environment sculpts destiny. Meanwhile, scientists push their instruments to the limit. Space-based observatories monitor ultraviolet emissions, tracking hydrogen and oxygen as ices split under solar heat. Ground-based telescopes measure polarization of light reflected from dust, probing the size and composition of particles. Even radio telescopes join in, detecting faint whispers of molecules like formaldehyde and methanol vented into space. Each dataset adds another brushstroke to the portrait of 2025's cluster. Patterns begin to emerge. One comet, unusually rich in carbon monoxide, produces a jet so powerful it alters its rotation. Another shows crystalline silicates in its dust, hinting at formation closer to the young sun before being exiled outward. A third displays nitrogen compounds rare in other comets, perhaps a relic of colder birth conditions. These differences remind us that comets are not interchangeable. They are archives, each one storing a different page from the story of planetary formation. And then there is the psychological pattern. As the skies brighten with cometary activity, people begin to project meaning onto them. For some, the spectacle is beautiful, inspiring awe at the scale of the cosmos. For others, it is unsettling. History has taught us that unusual celestial events often become canvases for human fear. The same minds that once saw comets as harbingers of doom now weave narratives about hidden planets, alien shepherds, or cosmic warnings. The human brain resists randomness. It demands stories. Scientists respond cautiously. In interviews, they emphasize probability, solar maximum, and detection bias. They remind the public that no comet in the cluster poses a threat to Earth. Yet they also admit, often in quieter tones, that the alignment is unusual, and that unusual events deserve attention. After all, science advances by investigating the improbable, not by dismissing it. For now, the skies remain crowded, and the interstellar visitor drifts silently among them. It neither explains nor denies the mystery. It simply exists, a foreign body crossing our stage at the same moment our own relics flare into brilliance. Whether coincidence or correlation, it forces us to look deeper, to question harder, to accept that sometimes the universe presents us with puzzles without solutions. And perhaps that is the point. Comets remind us that not everything aligns neatly with human categories. They are fragile, unpredictable, transient. They blaze, they vanish, and they leave behind nothing but questions. And in 2025, those questions hang brighter than ever, written across the sky in tales of light. When 7 comets flare in the same year, our instinct is to see design. But science, if it is to be honest, must look first at randomness. Clustering, after all, is not foreign to probability. It is the natural byproduct of chance. In statistics, patterns appear even in noise, runs of numbers, bursts of events, coincidences that feel uncanny but require no hidden hand. The difficulty lies in distinguishing between a true signal and an illusion, born of our own perception. Imagine tossing a coin 1,000 times. Somewhere in that sequence, you will see improbable runs, 10 heads in a row, perhaps even 15. Each run feels extraordinary, yet over many trials, it is inevitable. The same principle applies to comet arrivals. Given billions of years and trillions of potential bodies in the Oort cloud, it is not impossible for several bright comets to arrive together. Improbable, yes. Impossible, no. This concept is called clustering illusion, our tendency to interpret natural bunching as evidence of causation. We see shapes in clouds, conspiracies in coincidences, and meaning in random flares of celestial visitors. In 2025, the clustering of comets may be just that, an illusion heightened by our unique perspective. We live at one moment in cosmic time, and we cannot see the millions of years when comets arrive singly, unremarkably. To us, the rare burst feels significant. To the universe, it is simply one roll of the dice, and yet there is a subtlety here. Randomness does not mean absence of structure. The Oort cloud itself is not uniform. It is shaped by passing stars, by the galactic tide, by distant molecular clouds. Over long timescales, these influences may release groups of comets in waves, not in steady drips. From Earth's point of view, such waves may look like anomalies, but in truth, they are echoes of gravitational encounters long past. If a star brushed near our system 1,000,000 years ago, its influence could still be rippling into the inner solar system today, manifesting as the cluster of 2025. So, which is it? Random clustering or delayed consequence? At this stage, science cannot decide. The data are too thin, the sample too small. What matters is that both explanations remind us of humility. Either we are witnesses to an extraordinary coincidence, or we are catching the delayed whisper of an ancient cosmic meeting. Both stretch our imagination beyond the human timescale. 3I Atlas deepens the unease. Its interstellar trajectory excludes it from the Oort cloud story, but its timing welds it to the narrative in our minds. The rational answer is clear. It is coincidence. But coincidence is precisely what we struggle to accept when odds feel long. We ask, why now? Why this year? Why together? In truth, we may never know. But sometimes the role of science is not to resolve the question, but to clarify it, to show us where knowledge ends and wonder begins. Meanwhile, observations continue. The 7 comets provide a unique laboratory for studying statistical clustering in action. By comparing their orbits, scientists can test whether they truly behave like independent arrivals or whether subtle correlations link them. Early results favor independence. The comets come from diverse inclinations and aphelia, not from a single perturbed stream. That supports the randomness hypothesis. And yet, astronomers are cautious. History has taught them not to declare certainty too quickly. Public reaction is less cautious. Articles trumpet the idea of cosmic conspiracy, framing the clustering as a sign. Some invoke Planet 9, others whisper about alien intervention. For many, the scientific explanation, random clustering, is not satisfying because it lacks narrative drama. Human psychology craves stories, not statistics. It wants shepherds, causes, forces, not dice rolls. And so, the spectacle becomes a canvas for imagination as much as for science. This tension between science and story is itself part of the lesson. The universe is under no obligation to be dramatic. It is only under the obligation of physics. But our minds, built for survival in a chaotic world, cannot help but dramatize. We see meaning in coincidence because meaning is how we navigate reality. To recognize that impulse is to recognize both our brilliance and our limits. The 7 comets of 2025, then, are not just icy wanderers. They are mirrors, reflecting not only the sun's light, but our need to weave chance into story. And perhaps that is why this year feels so extraordinary. Not because physics has changed, but because we are here now to watch it unfold and to argue about what it means. If clustering illusion explains part of the 2025 spectacle, there remains another possibility: hidden gravity. In astronomy, gravity is the great sculptor, invisible yet omnipresent, bending paths and setting boundaries. When 7 comets appear together, some minds naturally ask, what unseen hand nudged them into alignment? The most obvious candidate is Jupiter. For centuries, it has shaped the solar system's small bodies. Its mass is so immense that it redirects asteroids, captures Trojan companions, and hurls comets into new orbits, or ejects them entirely into interstellar space. Without Jupiter, Earth would likely endure far more frequent impacts. It is both guardian and executioner, a cosmic shield and a slingshot. Could Jupiter be behind the 2025 cluster? Early orbital calculations seem to suggest otherwise. The comets show no common resonance with the gas giant. Their paths are varied, their origins scattered across the Oort cloud. Unlike Trojans or captured families, these comets do not march to Jupiter's rhythm. The great planet may influence them individually, but not in concert. Another hypothesis points farther out: Planet 9. For more than a decade, whispers have circulated about a massive unseen planet lurking in the distant solar system, perhaps 10 times Earth's mass, orbiting far beyond Neptune. The evidence is indirect. Odd alignments among certain trans-Neptunian objects that seem too orderly to be random. If such a world exists, its gravity could shepherd comets, subtly guiding their paths into the inner system. Could it explain 2025? Perhaps in theory, but not in timing. Planet 9, if real, operates over tens of thousands of years. Its gravitational influence is slow, cumulative, sculpting broad distributions rather than sudden synchronized arrivals. To credit it for the 2025 cluster is like blaming the slow pull of tides for a single rogue wave. The timescales simply do not match. Yet the suspicion persists because gravity is the one force we cannot dismiss. Unlike speculation about alien signals or cosmic conspiracies, hidden mass has precedent. Again and again, anomalies in orbits have led to discoveries, from Neptune in the 19th century to countless exoplanets in the 21st. If the comet's timing cannot be explained by chance alone, then hidden gravity is the next most reasonable suspect. Some even speculate about smaller shepherds, undiscovered dwarf planets in the Kuiper Belt, rogue planets passing near the Oort cloud, or stellar encounters in the recent galactic past. Each could, in principle, trigger a wave of comets, but each raises its own challenges. Dwarf planets lack sufficient mass, rogue planets are rare, and the chance of a close passage in recent history is slim. Stellar flybys occur, but usually on timescales far beyond a single human lifetime. So the dilemma remains. If not Jupiter, not Planet 9, not rogue shepherds, then what? Are we left only with probability? Science demands that we resist easy answers, but it also demands that we chase anomalies. And in 2025, the anomaly is bright across the sky. 3I Atlas complicates the picture further. Its hyperbolic path cannot be tied to hidden mass within the solar system. Its arrival is independent, yet its timing feeds the sense of design. To the human imagination, it feels like punctuation, a foreign object arriving to underline the mystery. Rationally, we know it is coincidence, but rationality does not erase the question. For now, astronomers treat the cluster as both problem and gift. The problem, it challenges models of comet distribution. The gift, it provides an unparalleled data set. If hidden gravity is at work, its fingerprints may be faint, buried in orbital parameters. Careful analysis of these comets may sharpen the search, either strengthening or weakening the case for unseen mass. In that sense, 2025 could become a pivotal year, not just for cometary science, but for the broader architecture of the solar system. Gravity is patient. It hides behind coincidence, waiting for instruments to improve, for patterns to emerge. Perhaps this year is only a spark, the first hint of a deeper truth. Or perhaps it is simply noise, and the comets will fade back into the statistical fog. Either way, science advances by asking the question, by refusing to let mystery settle into myth. When we speak of unseen forces in the solar system, gravity is the first and most natural suspect. But what if it is not gravity at all? The universe is not composed of mass alone. There are fields, radiation, winds of plasma, tides of charged particles sweeping outward from the sun. Could these electromagnetic forces, subtle yet pervasive, play a role in shaping cometary behavior and in amplifying the spectacle of 2025? On the surface, the idea seems compelling. After all, comets are extraordinarily responsive to solar wind. Their ion tails exist only because charged particles strip electrons from escaping gases, creating glowing streams aligned with the magnetic field of the heliosphere. When solar storms erupt, tails snap, bend, and ripple. Observers have watched these interactions in real time, sometimes seeing a comet's tail literally detach during a coronal mass ejection, only to regrow hours later. So why not imagine that such forces could do more? Not just shape the tails, but coordinate the arrivals themselves? Unfortunately, physics resists. Electromagnetic forces are indeed powerful, but only at small scales. They sculpt the visible features of a comet once it is already near the sun, but they cannot act across tens of thousands of astronomical units to draw multiple nuclei inward. The Oort cloud lies far beyond the reach of solar magnetism. There, only gravity rules. Still, there is nuance. The interplay of solar radiation and cometary surfaces may influence which comets brighten, which fade, and which fragment dramatically when they arrive. In other words, electromagnetic effects cannot explain the timing of the cluster, but they can explain why it feels so spectacular. The sun is at its maximum. Its storms are furious, and the comets that might otherwise have passed unnoticed are whipped into visible glory by an environment that exaggerates every detail. This exaggeration is precisely what makes 2025 so memorable. To the human eye, it looks like coordination. 7 comets blazing, their tails writhing in unison with solar flares, and an interstellar stranger sliding silently through the same sky. In truth, the comets are independent, but their responses to solar activity create the illusion of choreography. We are watching not design, but resonance, the resonance of multiple bodies caught in the same solar weather at the same moment. 3I Atlas adds another dimension to this resonance. Its restrained behavior contrasts with the flamboyance of native comets. Its tail, faint and narrow, does not respond as dramatically to solar storms. Perhaps its hardened surface shields it from sudden eruptions. Perhaps its chemistry is less volatile. Whatever the reason, it seems almost aloof, refusing to join the performance. And yet, that aloofness highlights the drama of the others, sharpening the sense of contrast. For scientists, this juxtaposition is invaluable. By comparing Atlas with native comets, they can isolate which features are universal and which are local. If Atlas remains muted under solar storms, while native comets flare violently, it suggests that long-term interstellar exposure fundamentally alters cometary surfaces. That insight is not just a curiosity. It is a clue about how small bodies evolve across different stellar environments, how fragile relics are transformed by radiation, and how chemistry is rewritten over millions of years. Outside the scientific sphere, speculation continues. Some argue that electromagnetic phenomena are themselves signs of deeper mysteries, that perhaps the sun's activity is not random, that its cycles may be linked to cosmic structures beyond our understanding. To most astronomers, this is unnecessary mysticism. But the fact remains, the sun's cycle and the cometary cluster have aligned, and the spectacle is greater because of it. Whether coincidence or correlation, the result is undeniable. The lesson of this year may be that not every anomaly requires exotic explanations. Sometimes physics itself is enough. Gravity governs arrivals, electromagnetism sculpts appearances, and human imagination weaves the two into narrative. The comets blaze, the interstellar stranger drifts, the sun storms, and together they create the illusion of cosmic orchestration. And perhaps that illusion is not to be dismissed, but embraced. Because in the end, science does not seek to strip away wonder, it seeks to refine it, to replace myths with mechanisms while leaving awe intact. In 2025, the mechanisms are clearer than ever, and the awe is greater still. If electromagnetic forces cannot explain the clustering, then perhaps we must return to the gravitational hypothesis, but with caution. Gravity is the universal architect, but it is also deceptive. It leaves signatures only in orbits, and orbits are complex, chaotic, and often ambiguous. The temptation is to search for a hidden body, a massive, unseen shepherd shaping these arrivals. Yet history reminds us, extraordinary claims require extraordinary evidence. The search for hidden planets has deep precedent. In the 19th century, irregularities in Uranus's orbit led astronomers to predict the existence of Neptune. The prediction was spectacularly confirmed in 1846, a triumph for celestial mechanics. That success cemented a pattern. When anomalies arise, perhaps there is an unseen mass to blame. Sometimes the guess is correct, but not always. The same method was applied to Mercury's orbit, whose perihelion advanced faster than Newton's laws could explain. For decades, astronomers hunted a hypothetical planet Vulcan near the Sun. It never existed. The anomaly was real, but the explanation required a new theory of gravity itself, Einstein's general relativity. The comet cluster of 2025 occupies a similar crossroads. Are we seeing Neptune or Vulcan? Is this the fingerprint of a hidden shepherd, or is it the hint of gaps in our understanding of long-term dynamics? The danger lies in choosing too quickly. If we assume a new planet, we risk chasing shadows. If we dismiss the anomaly, we risk overlooking discovery. For now, orbital calculations lean toward diversity, not unity. The 7 comets come from different directions, different inclinations, different aphelia. They do not trace back to a common perturbation. That weakens the case for a single gravitational shepherd. But weak evidence is not absence of evidence. It is the beginning of a question. Planet 9 remains the most persistent suspect. If it exists, its distant gravity could align orbits subtly, shaping the outer solar system. But as critics point out, its influence is slow, its patterns broad. It could explain long-term clustering of trans-Neptunian objects, but not the sudden convergence of 7 bright comets in a single year. That would require a more immediate trigger, something closer, something faster. And so far, no such body has been found. Some have speculated about passing stars. Over millions of years, stars drift near enough to brush the Oort cloud, stirring comets into motion. Astronomers have identified past and future encounters. Gliese 7 and 10, for instance, is predicted to pass within 0.2 light-years of the Sun in about 1 million years, disturbing countless comets. Could a lesser-known star have already passed close in the recent past, seeding the arrivals of 2025? Perhaps. But again, the evidence is lacking. No star has been identified whose trajectory fits the timeline. Others look inward, proposing that the apparent cluster is not physical at all, but observational bias amplified by the solar maximum. In this view, the comets are not more numerous, but simply more visible. The Sun, at peak activity, inflates their tails, exaggerating their brightness. Telescopes, now more sensitive than ever, detect what earlier generations would have missed. To a statistician, this is enough. To the imagination, it is not. And then quietly, there is the interstellar variable, 3I Atlas. Its timing is uncanny, its chemistry distinct, its orbit unrelated to the cluster. Rational analysis excludes it from causation. Yet human minds cannot exclude it from narrative. It has become the symbol, the outsider, whose presence at the scene suggests intention even when none exists. The odds of coincidence may be small, but coincidences happen. That is what makes them powerful. They tempt us to reject chance, even when chance is the simplest explanation. In the end, the gravitational hypothesis remains unresolved. There is no single shepherd, no smoking gun. The anomaly persists, but the data are insufficient. Perhaps future surveys will reveal more clusters, proving that 2025 was not unique. Or perhaps centuries will pass before such a spectacle occurs again, leaving this year a mystery suspended in time. Science thrives on such mysteries. They are the spaces between certainty, the questions that sharpen our instruments and refine our theories. The 7 comets, the restless sun, the interstellar traveler, all are pieces of a puzzle whose full picture may never be known. But to seek the answer is to practice science in its purest form, humble before the unknown, relentless in pursuit of clarity. If gravity is not the shepherd, some turn to another force, electromagnetism, not to explain the comet's arrival, but to interrogate how they behave once they are here. The distinction matters. Gravity shapes orbits, but electromagnetism sculpts appearances. And in 2025, the appearance of the comets has been nothing short of theatrical. Consider what a comet is: a nucleus only a few kilometers wide, cloaked in a coma that may stretch tens of thousands of kilometers, and a tail that can extend millions. The nucleus is trivial compared to the performance. 99% of what we see is not the body itself, but material being stripped away by sunlight and solar wind. That stripping is a fundamentally electromagnetic process. Charged particles stream outward from the sun at hundreds of kilometers per second. When they encounter the gases escaping a comet, electrons are ripped away. The result? Ionized atoms glowing with spectral lines, painting the coma blue-green. These ions are carried downwind by the magnetic field of the heliosphere, aligning the comet's tail with invisible forces. Each comet, then, is like a windsock in a storm, its direction dictated not by its own will, but by the currents of plasma. This year, those winds are furious. The solar maximum has unleashed storm after storm. Coronal mass ejections sweep through space like tsunamis of plasma, distorting comet tails in real time. Observers report tails bending abruptly, twisting into kinks, even disconnecting entirely before regrowing. Videos show luminous streaks flickering like candles in a gale. For the public, these changes feel alive, as if the comets were reacting emotionally to the sun's moods. For scientists, they are data-rich demonstrations of solar wind dynamics. 3I Atlas again refuses to play by the same rules. Its coma remains subdued, its tail faint and narrow, almost immune to solar tantrums. The contrast is striking. Native comets writhe under the sun's fury, while the interstellar stranger glides with quiet indifference. Why? The prevailing theory is that its surface has been hardened by eons in interstellar space, forming a crust that limits outgassing. Less gas means less material for the solar wind to grip, and so the comet shows restraint while others flare dramatically. It is as if Atlas is armored, a veteran of harsher environments than our sun can provide. This comparison offers scientists a natural experiment. The 7 comets act as fragile probes of the solar environment, their tails exaggerated by every storm. Atlas acts as a control, resisting the same forces. Together, they reveal not just the nature of comets, but the behavior of the solar wind itself. Never before has such a juxtaposition been available. But beyond the science, there is symbolism. To many watching from Earth, the native comets and the interstellar visitor embody 2 archetypes: the local and the foreign, the fragile and the resilient, the dramatic and the aloof. In their contrast, people see metaphors for culture, history, even politics. The spectacle becomes a mirror, reflecting not just cosmic dynamics, but human imagination. And this is where danger lurks. When patterns look too neat, too evocative, they tempt us to leap from physics to myth. Already, speculation circulates that Atlas is not just interstellar, but intentional, an object designed, not natural. Its resistance to solar storms, its arrival in the year of 7 comets, its alien chemistry, all become fodder for the idea of an artifact rather than a rock. Scientists push back, reminding the public of natural explanations, but the allure of mystery is powerful. The truth is more interesting than fiction. The contrast between Atlas and the seven comets is not evidence of conspiracy, but of diversity. It proves that the galaxy produces a spectrum of icy bodies, each shaped by unique conditions, each carrying different stories. To compare them is to read multiple chapters of cosmic history at once. In 2025, we are fortunate enough to have them open in front of us, if only briefly. The lesson is humility. Forces we cannot see, magnetic fields, plasma flows, galactic tides, sculpt the heavens with subtlety and power. Comets remind us of that subtlety. They are not merely omens or anomalies. They are laboratories, messengers, archives of processes that unfold across distances and timescales far beyond our own. And in this year of convergence, we glimpse both sides, the fragility of local wanderers and the resilience of a foreign traveler. Together, they tell us that the universe is vast, varied, and endlessly capable of surprising us. The beauty of science lies not just in observation, but in interpretation. Data, on its own, is raw. It is numbers, curves, and plots. Only when placed into context does it become meaning. And in 2025, the raw data of comets has become a crucible for competing interpretations: statistical, gravitational, electromagnetic, even speculative. One camp insists that randomness is sufficient. The clustering of seven comets is improbable, but not impossible. Given enough time and enough objects in the Oort cloud, such alignments will eventually occur. To them, 2025 is remarkable only because we are here to see it. Had it happened centuries ago, with no telescopes to record it, it would have passed unnoticed, vanishing into history. The spectacle in this view says more about human perspective than cosmic design. Another camp looks for deeper patterns. They argue that even if randomness can produce clustering, the precise timing, coinciding with solar maximum and the arrival of an interstellar traveler, is too neat to dismiss. They do not leap to aliens or hidden planets, but they suspect that our models of comet dynamics remain incomplete. Perhaps there are resonances in the Oort cloud we have not yet mapped. Perhaps galactic tides act in ways we do not fully understand. Perhaps unseen forces, subtle but natural, are at play. Then there are those who dwell on 3i Atlas. For them, coincidence is not enough. The interstellar object has become a symbol, a cipher, waiting to be decoded. They note its unusual chemistry, its muted activity, its uncanny timing. They speculate about its origin, about whether it was ejected by a violent planetary system, or whether it is part of a larger stream of interstellar debris passing through our neighborhood. In their view, Atlas is not an isolated traveler, but the first visible member of a hidden convoy. If true, then more interstellar objects may follow in years to come. The debate is vigorous, but beneath it lies agreement on one point. The opportunity is unique. Never before have multiple comets and an interstellar visitor been observed under the same solar conditions, with instruments capable of capturing every photon. The data being gathered in 2025 will feed research for decades. Orbital mechanics, solar-wind interactions, cometary chemistry, interstellar evolution, all are being rewritten in real time. Meanwhile, the public narrative diverges. In the scientific community, the tone is cautious, measured, and often skeptical. In popular culture, the tone is dramatic. Headlines speak of the year of the seven, of the interstellar shepherd, of a cosmic warning. Documentaries rush to production. Online forums overflow with speculation, blending fact with fiction. And while scientists may shake their heads, they also recognize the benefit. Curiosity is contagious, and spectacle is the best recruiter for new generations of astronomers. The comets themselves continue their journeys, indifferent to our debates. Some brighten, some fragment, some fade. Atlas glides steadily, still quiet, still enigmatic. Each night, observatories record their light curves, spectra, and images. Each morning, scientists parse the data, arguing over interpretations. The mystery deepens, not lessens, with every passing week. Perhaps that is the true lesson of 2025. The universe does not provide clear answers. It provides phenomena, rare, fleeting, sometimes bewildering. It is up to us to decide how to interpret them. Do we see coincidence or hidden order? Do we embrace mystery or demand resolution? The comets blaze regardless, their tails written across the sky, reminders that our categories are small compared to the cosmos. And so, the spectacle continues. Fragile wanderers disintegrating under solar heat, a foreign traveler refusing drama, and a star at its angriest painting them all with fire. To watch this convergence is to confront both the limits of knowledge and the boundlessness of wonder. By now, months into 2025, the cometary cluster has become more than an astronomical event. It has become a cultural moment. Night after night, people across the globe step outside, tilt their heads upward, and see faint streaks glowing against the stars. For many, it is the first time in their lives that the sky feels alive, dynamic, unpredictable. Telescopes in backyards and binoculars on balconies join billion-dollar observatories in chasing the same phenomena. For once, the boundary between professional science and public wonder nearly disappears. This blending of perspectives is rare. Astronomy often suffers from distance, distant galaxies, distant timescales, distant concepts too abstract for daily life. But comets are visceral. They are visible. They cut across the familiar constellations, intruding on a sky people think they know. In ancient times, this intrusion was seen as a violation, a warning. In the 21st century, it is seen as a spectacle, but also as a reminder that the cosmos is not static. The cluster also raises questions about prediction. Astronomers can calculate cometary orbits with precision once they are detected, but predicting which comets will appear bright enough to notice or which will fragment dramatically remains elusive. Some comets expected to shine instead fade into obscurity. Others, underestimated at first, flare into brilliance. In 2025, this unpredictability has been amplified. One comet has exceeded forecasts by an order of magnitude, while another fizzled into nothing weeks before perihelion. The spectacle is not only abundant, but capricious. 3I Atlas adds another layer of unpredictability. Despite intense monitoring, it refuses to behave in ways that satisfy expectations. Its surface is darker than anticipated, its outgassing muted, its tail stubbornly narrow. Some had predicted that, like 2I Borisov before it, it would flare into vivid activity under solar heating. Instead, it has remained reserved, almost reluctant. For scientists, this restraint is not disappointment, but data. It suggests that interstellar comets may evolve differently from local ones, hardened by radiation, shielded by crusts, carrying chemistry shaped by alien stars. The comparisons continue. Native comets writhe under solar storms, their tails snapping and twisting in visible arcs. Atlas glides, nearly unchanged. The juxtaposition has become iconic, images of multiple comets flaring brilliantly while the interstellar visitor hangs quietly nearby. The public interprets it as symbolism. Scientists interpret it as evidence. Both are right in their own way. Meanwhile, the deeper question persists. What does the cluster mean for our understanding of the solar system? If it is coincidence, then it is a spectacular example of statistical rarity. If it is correlation, then something unseen, gravitational, galactic, or otherwise, has shaped it. Either way, it forces us to refine our models. It pushes the boundary between what we think we know and what remains uncertain. The cluster also reveals the fragility of scientific certainty. Before 2025, models predicted steady trickles of comet arrivals, not bursts of 7. Those models are not wrong, but incomplete. They may need to incorporate galactic tides with more nuance, or to simulate stellar perturbations with greater precision. Science advances not by clinging to certainty, but by adjusting to anomalies. And this year, the anomalies are written across the sky. Culturally, the event has already left its mark. Artists paint comets into murals. Writers spin them into metaphors. Musicians compose scores inspired by the sight of multiple tails stretching above the horizon. The comets have transcended science, becoming symbols of transience, of convergence, of fleeting beauty. They remind us that wonder is not confined to laboratories, but woven into human expression. And yet, amid the beauty and speculation, a note of humility lingers. The comets are not here for us. They are icy relics obeying physics, indifferent to meaning. Atlas is not a messenger, but a stray. The universe is not orchestrating a performance. It is only unfolding, as it always has, in patterns too vast for us to fully grasp. What makes 2025 extraordinary is not design, but timing. We are alive now to witness it, and that is enough. As the year progresses, patterns begin to emerge, not in the heavens, but in the human response. The comets of 2025 have become a Rorschach test for culture, science, and imagination. To astronomers, they are data points. To poets, they are metaphors. To the anxious, they are warnings. To the curious, they are invitations. In this way, the cluster is as much a mirror of humanity as it is a display of cosmic mechanics. In the scientific community, the focus remains on precision. Teams across the world exchange orbital data daily, refining trajectories to fractions of arcseconds. Spectrographs reveal not only water and carbon monoxide, but rare molecules like formaldehyde and acetylene, each offering hints about where the comets formed and what conditions they endured. Dust collectors on spacecraft trap microscopic grains, hoping to decode their mineralogy. Every comet adds another layer to the map of our origins. The interstellar visitor, 3I Atlas, complicates this map. Its spectrum diverges from the local norm. Ratios of carbon chains to oxygen are skewed. Its dust grains reflect light differently, darker and less polarized than those of the native comets. These differences are small but profound. They prove that not all planetary nurseries produce identical recipes. Somewhere beyond our sun, a different chemistry reigned, and Atlas carries its imprint across the gulf of space. To study it is to glimpse the diversity of planetary systems, to realize that even in something as simple as ice and dust, the galaxy holds variation. For the public, nuance gives way to narrative. Documentaries frame Atlas as the stranger among seven. Headlines ask whether it is the cause, the shepherd, the omen. Conspiracy forums declare it artificial, a probe disguised as a comet. Scientists resist these leaps, but the narrative momentum is unstoppable. Human minds crave stories, and the 2025 sky seems to offer one written in light. Meanwhile, the comets themselves continue their unpredictable behavior. One brightens explosively, briefly rivaling the brightest stars before fading within days, a reminder that cometary forecasts are fragile. Another fractures into three smaller pieces, each with its own tiny tail. Astronomers scramble to update predictions, their models challenged by every surprise. For students of orbital mechanics, it is a live demonstration that theory must bend to reality, not the other way around. Amid the noise, deeper questions sharpen. What does it mean that such clustering is possible? Does it suggest that the Oort cloud is richer than we imagined? Does it hint at recent disturbances, passing stars, galactic tides that we have yet to fully map? Or does it simply remind us that probability, stretched across billions of years, will eventually produce patterns that feel unnatural but are not? The paradox is clear. The more data we gather, the more mystery we find. Each comet adds not closure, but complexity. Each fragment reveals not an answer, but a deeper puzzle. Science thrives in this paradox, but it is also humbled by it. For every law of physics we wield, the universe offers phenomena that refuse to fit neatly. And then, always, there is the silence of Atlas. The interstellar traveler remains reserved, its activity muted, its profile enigmatic. Observers wait for a dramatic outburst that never comes. Instead, it glides steadily, indifferent to spectacle, a reminder that not all mysteries perform for us. Perhaps that is its greatest lesson, that the universe is not obliged to satisfy human expectations. Still, the timing is haunting. 7 local comets blaze, flare, fragment. The stranger drifts through at the same moment. Together, they create a tableau too striking to ignore. Whether coincidence or not, it feels like a message, and humanity cannot resist reading it. The question is not whether the cosmos speaks, but whether we are listening to ourselves. The comets are real, the interstellar visitor is real, the data are real. The meaning, however, is ours to invent. And in that invention lies both our brilliance and our vulnerability. To watch a comet is to watch a relic unravel. Each tail, each flare of brightness is a slow act of self-destruction. These objects were forged billions of years ago in the infancy of the solar system, frozen archives of a time when planets were still coalescing. Their ices preserve molecules that predate Earth itself. When sunlight touches them, those archives are erased, sublimated into space as fleeting spectacles. Every bright comet is both a discovery and a loss. This duality is why astronomers pursue comets so relentlessly. They are windows into the past, but windows that vanish as we gaze through them. In 2025, the sense of urgency is magnified. 7 comets blaze at once, and an interstellar object joins them. Each is a book in a library that will soon burn. Every observation matters, because once the ice is gone, the story it carried is gone too. Already, insights are emerging. One comet's dust shows crystalline silicates, minerals that form under high temperatures, implying it was born closer to the sun before being flung outward. Another contains ammonia-rich ices, suggesting formation in a colder, more distant zone. Together, they prove that the Oort cloud is not homogeneous, but a jumble of exiles from across the early solar system. To map its diversity is to map our own chaotic beginnings. 3i Atlas provides the contrast, a book not from our library, but from another entirely. Its chemistry diverges just enough to remind us that planetary systems are not copies of one another. Somewhere else, under another star, conditions differed, and Atlas carries the memory of that alien nursery. Its restraint, the muted outgassing, the faint tail, may reflect those origins. Hardened by cosmic rays and interstellar dust, it arrives less fragile, less willing to display itself. But in its silence lies a different kind of story, not performance, but endurance. The symbolism is inescapable. Local comets are fragile, dramatic, fleeting. The interstellar visitor is quiet, resilient, enduring. Together, they embody two modes of existence, brilliance and survival. Humanity, watching from Earth, sees reflections of itself in both. We too flare brightly in moments of spectacle, yet we too seek endurance across vast stretches of time. As the cluster continues, the boundary between science and culture blurs further. Museums host late-night events where telescopes track the comets in real time. Schools organize viewings, teaching children that what they see in the sky is not myth, but physics, and yet still wondrous. Writers describe the year as a celestial festival, while some religious voices interpret it as a sign, echoing ancient traditions. The same lights inspire data collection and poetry, caution and prophecy. Amid this human response, the comets remain indifferent. They follow their paths, flare under heat, fracture when stress exceeds cohesion. One disintegrates entirely, scattering into a diffuse cloud that slowly dissipates. Another reveals jets of gas that shift its rotation, altering its spin in ways that may hasten its breakup. Each event is both tragedy and opportunity. Tragedy because the comet is lost. Opportunity because fragments reveal secrets hidden for eons. For scientists, the challenge is to balance urgency with discipline. Data floods in, images, spectra, light curves, simulations. Teams work through the night, analyzing, publishing, debating. Hypotheses rise and fall within weeks. Some argue that the clustering is purely random, others that it is a delayed echo of a stellar flyby, others still that it hints at galactic tides. The consensus remains elusive, but consensus is not the goal. The goal is clarity, and clarity takes time. Perhaps in the end, the comets will leave us with more questions than answers, but questions are the engine of science. The spectacle of 2025 is not just about comets. It is about how humans confront the unknown. Do we see coincidence or design, chaos or order, silence or message? The answers matter less than the pursuit itself. And when Atlas departs, vanishing back into interstellar night, it will take its secrets with it. The 7 comets, too, will fade, their tails dissolving into invisibility. What remains will be the data, the debates, the memories of a year when the sky was crowded with questions. Comets are not just archives of the past, they are also agents of change. Throughout Earth's history, they have delivered both destruction and possibility. Impacts have scarred the moon, reshaped planets, and perhaps even altered the course of evolution. Some scientists argue that comets seeded Earth with water and organic molecules, laying the groundwork for life itself. Others warn that they remain threats, capable of catastrophic collisions. In 2025, watching 7 comets blaze while an interstellar visitor drifts nearby, we are reminded of both roles, gifts and dangers intertwined. For now, none of the 7 poses a threat to Earth. Their orbits carry them safely past, their closest approaches far from collision. Yet their visibility revives public awareness of the risks. News outlets resurrect discussions of planetary defense, of asteroid redirection technologies, of what humanity could do if one day a comet's orbit intersected our own. The contrast is striking. In the same breath, comets are celebrated as wonders and feared as warnings. This duality shapes the scientific effort. Instruments measure not only brightness, but density, not only tails, but trajectories. By studying the cluster, astronomers refine models of impact probability. Each orbit mapped, each parameter measured, contributes to a growing defense strategy. Knowledge is both curiosity and shield. 3I Atlas, again, stands apart. Its hyperbolic path guarantees it will never return. It is not a threat, it is a messenger. Yet even here, imagination strays toward unease. Some speculate, what if interstellar objects could one day collide with Earth? Unlike native comets, whose reservoirs and frequencies we understand, interstellar visitors are unpredictable. They arrive unannounced from directions we cannot anticipate. The thought is unsettling, but the rarity of such encounters offers reassurance. In billions of years, Earth has likely faced very few, if any. The deeper significance of Atlas is not threat, but perspective. It reminds us that our solar system is not isolated. It drifts through the galaxy, intersecting with debris from other stars, sharing material across unimaginable distances. Life on Earth may be bound to one planet, but the matter that makes us is part of a cosmic network. Each interstellar visitor is proof of that interconnectedness. Meanwhile, the 7 local comets continue their unpredictable displays. One, battered by solar radiation, suddenly fractures into dozens of fragments, creating a temporary mini-swarm that dazzles observers with multiple faint tails spreading outward. Another fades without spectacle, disappointing those who had hoped for brilliance. Together, they demonstrate both the drama and the humility of comet science. Predictions are fragile, surprises inevitable. The spectacle also shifts how we perceive time. For humans, a year feels long. For comets, it is nothing. Their journeys from the Oort cloud span millions of years. The fact that we are alive now during the brief moment when 7 arrived together is itself extraordinary. The universe does not time events for us. We simply exist at a lucky or unlucky intersection. That realization humbles scientists and laypeople alike. Culturally, the comets inspire more than fear or wonder. They spark reflection. Writers describe them as metaphors for impermanence, for the fleeting nature of beauty. Philosophers see them as reminders that meaning is constructed, not given. Religious voices interpret them as signs, weaving them into narratives of destiny. The same lights in the sky generate 1,000 different readings, none objectively wrong, each shaped by human need. Perhaps that is the most important lesson of the cluster. The cosmos is silent. It does not assign meaning. But when comets blaze, we do. We turn physics into stories, randomness into pattern, chance into significance. In doing so, we reveal not just the nature of the universe, but the nature of ourselves. The comets will fade. Atlas will depart. But the questions they raise about origins, about fragility, about chance and meaning will remain. And in the end, those questions may prove more enduring than any tale across the sky. In many ways, the cometary cluster of 2025 has become a live experiment in perception. The science is clear. Comets are icy relics, driven inward by gravity, sculpted by solar radiation. Yet the human response is less about mechanics and more about meaning. Every glowing streak in the night sky is interpreted, reinterpreted, and layered with significance. It is not the comets alone that matter, but the stories we build around them. Consider how swiftly interpretations diverge. In laboratories, scientists debate chemical ratios and orbital mechanics. In online forums, people speculate about signs and warnings. In art studios, painters trace the arcs of comet tails across canvases, turning physics into metaphor. In classrooms, children look through telescopes and ask if the comets are talking to each other. The same phenomenon splinters into countless narratives, each reflecting the priorities of its audience. This is not new. For millennia, comets have been canvases for projection. Ancient Chinese astronomers recorded them as omens tied to dynastic cycles. Medieval Europeans saw them as harbingers of plague and war. Indigenous traditions often wove them into cosmologies, symbols of renewal as much as destruction. The difference today is not the instinct, but the tools. Where once people wrote myths, now they write simulations. Where once they drew fiery swords in the sky, now they publish orbital plots and spectrographic data. Yet beneath both lies the same impulse, to make sense of fleeting light. The presence of 3I Atlas intensifies this impulse. Its timing, its alien chemistry, its quiet behavior, all invite interpretation. Rationally, it is just another visitor, ejected from a distant star system, passing silently through. Emotionally, it feels like punctuation. 7 local comets blaze with chaotic energy, while the interstellar traveler glides with quiet restraint. Together, they compose a narrative too striking to ignore, the noisy chorus of the familiar and the quiet solo of the foreign. For astronomers, the challenge is to balance wonder with discipline. Data must be stripped of myth, analyzed without bias. Light curves must be disentangled from narrative. Every fragmenting nucleus, every spectral line, every orbital perturbation must be treated as evidence, not omen. Yet even scientists are not immune to awe. Many admit privately that the cluster feels uncanny, that the timing stirs questions larger than equations can settle. The year also highlights the fragile line between knowledge and speculation. Planet 9 remains unconfirmed, stellar flybys remain hypothetical, and galactic tides remain poorly modeled. The temptation to invoke hidden forces is strong, especially when chance feels unsatisfying. But science demands restraint. To leap to conclusions too quickly risks mistaking coincidence for causation, illusion for discovery. History warns us. Sometimes anomalies reveal Neptune. Sometimes they reveal Vulcan. The trick is patience. Meanwhile, the comets continue their unpredictable performances. One erupts in a sudden flare, bright enough to cast faint shadows on dark landscapes, stunning observers who had never before seen night illuminated by a comet. Another fades inexplicably, its tail collapsing as though the nucleus sealed itself against further outgassing. Atlas, ever quiet, drifts on, its presence almost ghostly beside the native flares. Together, they create a sky both dazzling and confounding. The greatest gift of the 2025 cluster may not be answers, but questions. It reminds us that science thrives not on certainty, but on curiosity. The comets challenge models, Atlas challenges assumptions, and together they force us to re-examine the solar system's dynamics. In doing so, they keep science alive, not as a repository of facts, but as a living dialogue with the unknown. For the public, the comets serve another role. They reconnect humanity with the sky. In an age dominated by screens, people step outside to watch real light from real objects billions of years old. They are reminded, if only for a moment, that the universe is vast, dynamic, and indifferent, and that in its indifference lies beauty. The cluster will pass. Atlas will vanish into interstellar darkness, but 2025 will remain in memory as the year the sky was crowded, the year randomness looked like design, the year comets reminded us not only of physics, but of wonder. Every comet is a messenger, but not all messages are the same. Some arrive quietly, faint smudges barely perceptible in the darkest skies. Others arrive flamboyantly, bright enough to dominate headlines and inspire myths. In 2025, we are receiving both kinds simultaneously, and that contrast is reshaping how we think about comets, not as singular anomalies, but as a spectrum of behaviors, from fragile fireworks to stoic survivors. One of the most striking lessons of this year is how fragile comets truly are. 2 of the 7 have already disintegrated, their nuclei shattered by thermal stress and rotational forces. Their tails expanded briefly into diffuse veils before fading into invisibility. To scientists, these moments are bittersweet. The destruction of a comet is also the revelation of its interior. Dust spectra reveal silicates and organics preserved since the dawn of the solar system. Jets of gas expose layers buried for billions of years. Every breakup is both an ending and a beginning, erasure and discovery at once. Others among the 7 behave differently. One brightens far beyond forecasts, perhaps because a volatile, rich pocket of ice lies close to its surface, venting explosively under sunlight. Another dims, underperforming compared to predictions, its surface sealed under a crust of refractory dust. The diversity is remarkable, a reminder that comets are individuals, not interchangeable specimens. Each one tells a different story about where in the solar nebula it formed, what collisions it endured, and how time has reshaped it. And then always there is 3I Atlas. Its refusal to flare like the others has become a puzzle of its own. Despite closer approach, despite solar heating, it remains muted, emitting only a faint tail. This restraint reinforces the theory that interstellar comets evolve differently, hardened by long exposure to cosmic rays, perhaps even coated in exotic compounds not common in our system. Instead of crumbling in spectacle, Atlas endures in silence, a messenger of resilience rather than fragility. The juxtaposition has not gone unnoticed. Media outlets draw comparisons. 7 voices shouting, 1 whispering. Poets write of the chorus and the stranger. Scientists remain cautious, but even in technical papers the contrast is noted. The year has become a natural experiment, not just in physics, but in symbolism. We are reminded that science and story are never entirely separate. That meaning creeps into data whether we welcome it or not. Beyond symbolism, the cluster is reshaping methodology. With multiple comets active at once, astronomers can test hypotheses that normally require decades of waiting. How do different compositions respond to identical solar storms? How does brightness evolve under similar conditions? What distinguishes comets that fragment from those that survive? Normally, these questions require comparisons across centuries of records. In 2025, the answers emerge night by night. The solar maximum amplifies these lessons. Coronal mass ejections buffet tails in synchrony, providing a controlled experiment imposed by nature. Some tails kink dramatically, others ripple, others barely react. The diversity of responses under the same solar event speaks volumes about differences in composition and structure. It is as if the sun is conducting a stress test, and each comet reveals its resilience, or lack thereof, in real time. For the public, These differences translate into spectacle. Skywatchers report seeing multiple tails at once, faint arcs stretching across constellations. Amateur photographers capture scenes that look like paintings, luminous fans of light crisscrossing above the horizon. For many, this is the first time the night sky is felt alive, changing from week to week, demanding attention. The sense of wonder is palpable, but wonder carries risk. When phenomena feel uncanny, they invite speculation that leaps beyond evidence. Some claim the clustering proves hidden forces. Others insist Atlas is artificial. Still others weave myths of destiny. Scientists answer with patience, pointing to probability, solar cycles, and detection bias. Yet even they admit privately that the convergence feels rare enough to stir unease. Perhaps that is the enduring lesson of 2025, that science and imagination are partners, not enemies. The comets do not care what stories we tell. They sublimate, fragment, and vanish, indifferent to meaning. But in watching them, we are reminded of our dual nature. We measure with instruments, and we dream with symbols. Both are true, and both are necessary if we are to make sense of the fleeting fire in the sky. By late 2025, the cluster of comets has entered not just astronomy, but memory. Each night's observations add data, but each week's spectacles add stories. Already people speak of the year of comets as though it were a chapter in history, something future generations will recall not through calculations, but through images, paintings, and myths. The 7 native comets, though diverse, share one trait: impermanence. Their brightness peaks, then fades. Their tails stretch, then dissolve. For many observers, the sight is bittersweet. To see a comet at its most brilliant is also to know it is dying, its ice is spent, its fragments drifting away. Comets are reminders that beauty and fragility are inseparable. They are not stars, eternal in human timescales, but ephemeral flames that vanish even as we admire them. 3I Atlas is the opposite. It refuses to flare, refuses to fragment, refuses to perform. Its faintness is persistence, its silence, endurance. Where the 7 natives are fireworks, Atlas is a stone. It will not return, but it will not break either. In that stubbornness lies its own kind of drama, not spectacle, but survival. For scientists, that survival is data, proof of how interstellar exposure sculpts comets into something tougher, more reserved. For the public, it is mystery, an object that seems to carry secrets it will never share. The scientific community continues to wrestle with interpretation. Orbital analyses show no single shepherd guiding the 7, no hidden mass that can explain their timing. Statistical models confirm that clustering, while rare, is possible. Solar maximum explains their exaggerated brightness. Taken together, the explanations are sufficient. And yet, the sense of coincidence lingers. To live at the exact moment when 7 comets converge and an interstellar stranger arrives feels improbable enough to stir even skeptical minds. Some researchers speculate that the cluster may be a delayed consequence of an ancient stellar encounter, a passing star that brushed the Oort cloud millions of years ago, sending waves of comets inward. If so, the arrivals of 2025 are echoes, delayed ripples of a cosmic meeting long forgotten. This hypothesis cannot yet be proven, but it resonates. It frames the spectacle not as chance, but as history unfolding across vast timescales. The public, however, rarely asks for such nuance. For many, the comets are simply signs of beauty, of change, of destiny. Artists carve them into sculptures, Musicians compose symphonies named for Atlas. Writers craft stories where comets herald turning points in human history. Once again, science and culture intertwine, each feeding the other. The data inspire art. The art inspires curiosity. Curiosity drives more people to look up. And looking up may be the most important outcome of all. In an age when attention is fractured, the sky has demanded unity. Across cities, villages, deserts, and oceans, people have stepped outside to watch the same lights. They have seen tails curling across constellations, faint to the naked eye but brilliant through binoculars. For many, it is the first direct connection to the cosmos they have ever felt. That connection may inspire new scientists, new thinkers, new dreamers. If so, the legacy of 2025 will last longer than any comet. The comets themselves continue to change. One fragments into a dozen small pieces, creating a diffuse fan that slowly fades. Another brightens beyond expectation, briefly rivaling Venus before vanishing weeks later. Atlas remains steady, neither brightening nor collapsing, its faintness a kind of defiance. Together, the 8 bodies form a mosaic of outcomes: fragility, spectacle, endurance. The spectacle will not last much longer. The comets are already receding from the sun, their tails shortening as their ices retreat into dormancy. Atlas, too, is on its way out, speeding toward the stars from which it came. Soon, the sky will empty, returning to quiet. But the memory will remain, and so will the questions. Was it chance? Was it history? Was it design? Or simply the universe reminding us of its vastness? Perhaps the answer does not matter. What matters is that we were here to witness it. That in 2025, the cosmos gave us a fleeting alignment that stirred both science and soul. That comets, fragile and foreign, reminded us of our place, not at the center of the story, but as participants in a universe that writes its own. As the cluster begins to wane, astronomers take stock. The flares have been recorded, the fragments cataloged, the spectra archived. What remains now is not spectacle, but analysis. Data that dazzled in real time must now be parsed with patience, transformed into models, theories, and eventually, understanding. Yet the questions raised by 2025 resist easy resolution. One of the most pressing is statistical. Just how rare is this cluster? Some models suggest that 7 bright comets within a year is a 1 in 10,000 event. Others argue that with modern surveys, such bursts may be more common than we realize, simply unnoticed in the past. After all, the history of astronomy is biased. Ancient observers recorded only the brightest visitors, those visible without instruments. Entire generations of faint but fascinating comets passed unseen. Perhaps 2025 feels unique only because our technology has caught up. Yet, even accounting for bias, the coincidence remains striking. Not only the number of comets, but their simultaneity with solar maximum and with the arrival of 3I Atlas. Each element alone could be explained. Together, they create a narrative that feels improbable. And so, science must tread carefully between explanation and acknowledgement of mystery. The fragmentation events add complexity. 2 comets shattered completely, their remnants dispersing into diffuse clouds. Another split into 3 sizable pieces, altering its orbit slightly. These breakups provide critical insight into cometary physics, how rotation, jets, and thermal stress tear fragile nuclei apart. They also underscore the fragility of predictions. A comet expected to blaze for months may vanish in days. For planetary defense, this is sobering. What if a dangerous comet fragmented unpredictably before impact? The dynamics of survival and disintegration matter not just for curiosity, but for safety. Meanwhile, Atlas continues to confound expectations. Even at closest approach, it remains subdued, refusing the flamboyance of local comets. Its dark surface absorbed heat without dramatic venting. Its tail stretched faint and narrow, barely visible, except through sensitive instruments. For some scientists, this was anticlimax. For others, it was revelation. Atlas has shown that interstellar comets may not behave like ours. They may arrive armored, their chemistry alien enough to dampen spectacle. If so, each interstellar visitor is not just a curiosity, but a warning. Our assumptions are local, not universal. The cultural momentum persists as well. Though some comets fade, their imprint lingers. Social media threads document the Seven, with amateur photos stitched into global mosaics. Artists release works inspired by tales twisting across constellations. Writers fold Atlas into allegories of the foreign and the familiar. The cluster has left the domain of astronomy alone. It now belongs to memory, myth, and imagination. Scientists, for their part, look ahead. The data collected in 2025 will take years to analyze fully. Already, proposals circulate for follow-up missions to intercept future interstellar objects or to prepare rapid response probes for cometary swarms. The lesson is not just that comets surprise us, but that we must be ready when they do. And always beneath the calculations lies humility. The comets remind us that the solar system is not stable but dynamic, not predictable but chaotic in detail. The Oort cloud stretches beyond imagination, stirred by forces we cannot always anticipate. The galaxy too intrudes, its tides, its stars, its debris streams. We are passengers in a cosmic current far larger than our models can fully capture. Perhaps then, the greatest legacy of 2025 is not the comets themselves, but the questions they leave behind. Questions about randomness and resonance, about fragility and endurance, about local and interstellar origins. Questions that cannot yet be answered, but that sharpen our pursuit of knowledge. And when future generations look back, perhaps they will see 2025 not just as the year of 7 comets and 1 interstellar visitor, but as a turning point, the moment when coincidence forced us to ask harder questions about the universe we inhabit. By autumn of 2025, the cometary spectacle has begun to recede. Tails that once stretched across constellations are shrinking. Brightness that once dominated skies has dimmed. For casual observers, the show is fading, but for astronomers, the real work is only beginning. Now comes the painstaking task of turning observation into understanding, spectacle into science. One focus is chemistry. Spectra taken during perihelion revealed not only familiar molecules, water, carbon dioxide, carbon monoxide, but rare compounds as well. In one comet, scientists detected methanol in unusual abundance. In another, ethane dominated. These subtle differences hint at formation zones within the early solar system. Warmer regions producing one chemistry, colder regions another. The Oort cloud, then, is not a uniform shell, but a mosaic of histories. Each comet a frozen fingerprint of where and how it formed before being scattered outward. Dust samples, captured by high-altitude collectors, reinforce this diversity. Some grains show crystalline silicates, evidence of formation in high-temperature regions near the proto-sun. Others show amorphous structures, products of colder zones. Mixed together in the Oort cloud, They tell the story of a chaotic infancy, planets forming, migrating, scattering leftovers into exile. Each comet of 2025 adds a chapter to this sprawling narrative. And then there is 3I Atlas. Its chemistry stands apart. Ratios of carbon to oxygen deviate from solar norms. Its dust reflects light with unusual polarization, suggesting surface processing under harsher radiation than our sun provides. In short, Atlas confirms that other stellar nurseries do not build their comets exactly as ours do. To study it is to glimpse alien chemistry firsthand, not in distant exoplanet spectra, but in a body we can see, measure, and even touch with our instruments. The comparison between Atlas and the seven natives sharpens another lesson: resilience versus fragility. The local comets flare, fragment, and vanish, their beauty inseparable from destruction. Atlas endures, dim and steady, refusing drama. It silences data, but also metaphor. It is the stoic among the flamboyant, the survivor among the spendthrifts. Together, they remind us that survival and spectacle are rarely the same. The fading of the comets also highlights another truth. Human attention is brief. At first, the cluster dominated headlines. Every flare was news, every photo viral. But as brightness declines, so too does coverage. Other stories replace them. Only scientists, artists, and the most devoted skywatchers continue to follow. For the majority, the memory of 2025 will become a story told rather than an experience lived. This, too, is natural. Comets remind us not only of cosmic impermanence, but of human impermanence, the fleeting nature of our focus, our fascination, our awe. Yet even as public attention wanes, data remain. Petabytes of images, terabytes of spectra, countless measurements await analysis. Graduate students will spend entire careers unraveling what 2025 revealed. New models of orbital dynamics will emerge. New theories of interstellar chemistry will take shape. The legacy of this year is not confined to its spectacle. It is embedded in the slow work of science, in the cumulative building of knowledge. Meanwhile, speculation does not fade as quickly. Some insist the cluster was orchestrated by hidden planets, by alien intelligence, by forces beyond science. Scientists remind us that probability, though unsatisfying, is sufficient. Still, the sense of unease lingers. Coincidence? This perfect feels like design, even if it is not. And perhaps that is the deepest lesson, that human minds will always reach for meaning, even in silence. As the comets retreat and Atlas speeds outward, the skies grow quieter. But their absence is not emptiness. It is echo. Echo of a year when the heavens seemed alive, when chance looked like intention, when fragile wanderers and a foreign traveler crossed paths above a world of watchers. That echo will remain long after the tales have dissolved. By the closing months of 2025, the spectacle of comets has entered its final act. The skies that once seemed crowded now begin to empty. Only a few of the seven remain visible to the naked eye, and even those are fading. Their tails, once long luminous banners, shorten into wisps, dissolving into the background of stars. For many, the disappearance feels like the end of a festival, the dismantling of decorations after a grand celebration. Yet in truth, the comet's departure is not an ending, but a continuation of cycles far larger than human time. For astronomers, this is the most delicate moment. As brightness declines, measurements become more difficult, but often more revealing. Fainter comets expose subtler processes, slow jets of gas, gentle shifts in rotation, dust grains drifting into diffuse clouds. Where the spectacle of early months provided drama, the fading provides detail. In science, endings are not always less valuable than beginnings. Some of the comets have left permanent marks. One fragmented so thoroughly that its remnants will continue orbiting as a diffuse stream, perhaps one day intersecting Earth's path and producing a new meteor shower. Another altered its rotation enough to destabilize its shape, ensuring that the next perihelion, thousands of years hence if it survives at all, will likely be its last. Each outcome is unique, and together they expand the catalog of cometary fates. 3I Atlas is also receding, accelerating back into interstellar night. Its faintness persists, its profile unchanged. Observers note that even as it exits the inner solar system, it shows none of the flamboyant behavior of its native counterparts. It entered quietly and leaves quietly, an outsider slipping past without ceremony. Yet in its restraint lies perhaps the greatest revelation. Not all comets are destined for drama. Some are designed, by origin and by history, simply to endure. The contrast between Atlas and the native seven sharpens as they fade. The locals have burned brightly and collapsed quickly. Atlas has remained muted but steady. To many scientists, this is confirmation that interstellar comets evolve differently, that exposure to harsher environments hardens them, altering chemistry and surface. To others, it is a reminder that our expectations are provincial, shaped by one solar system's history. The galaxy holds more diversity than our models can predict. Culturally, the fading does not erase the memory. The year of comets has been documented in millions of images, in hours of video, in countless essays and artworks. Museums curate exhibits titled The Cluster of 2025. Schools preserve telescope footage for students not yet born. The event is already entering collective history, much as Halley's Comet shaped chronicles of the past. Long after the light has gone, the story will remain. But stories, unlike data, bend. Some will emphasize the science, a rare statistical cluster explained by randomness and resonance. Others will emphasize symbolism. 7 comets blazing as a foreign traveler passed among them, a cosmic chorus around a solitary voice. Both are true in their own way. The comets existed as physics, and they existed as meaning. Humanity will preserve both. For scientists, the task is clear. Years of work remain, parsing every orbit, every spectrum, every fragment. The anomalies must be resolved, or, if they cannot, acknowledged as mysteries. Whether 2025 becomes remembered as coincidence, as consequence of ancient perturbations, or as evidence of processes yet unknown, it has already reshaped cometary science. The cluster has expanded the frontier of what is possible, and in doing so, reminded us of the humility required when studying a universe larger than our models. And for the public, the lesson is simpler: to look up, to remember that above the noise of daily life, the cosmos occasionally offers a gift, fleeting, fragile, dazzling. A reminder that we are part of a system not just of planets and stars, but of wanderers that come and go, carrying with them both science and story. The comets of 2025 will not return in our lifetimes. Atlas will never return at all. But their light has already outlived their presence. They have joined the tapestry of memory, one more reminder that even in silence, the universe speaks, if only we are listening. By the end of 2025, the great convergence has nearly dissolved. What once seemed like a cosmic gathering has scattered into silence. Only faint traces remain, dim comets barely visible in telescopes, tails no longer flamboyant, but reduced to thin wisps of dust. 3I Atlas has already begun its departure into the dark, its hyperbolic path ensuring it will never return. The curtain is falling, but the resonance of what was witnessed will linger for decades. For astronomers, this is the moment of transition, from observation to interpretation. The frenzy of nightly tracking has slowed. Telescopes now capture only faint signatures, while teams shift focus to the wealth of data already collected. Computers hum with orbital integrations, simulating perturbations over millions of years. Laboratories examine captured dust grains under electron microscopes, parsing their mineralogy atom by atom. The spectacle has ended, but the science is just beginning. Early analyses already yield surprises. One comet revealed an unexpectedly high ratio of nitrogen isotopes, suggesting it formed in a region colder than any previously modeled for our solar system. Another displayed complex organics, including precursors to amino acids. These discoveries fuel the enduring question: did comets help seed life on Earth? If so, then the diversity revealed in 2025 suggests that life's ingredients may be abundant not just here, but throughout the galaxy. Atlas complicates this picture. Its chemistry diverges from every local comet studied. Ratios of volatiles hint at an alien nursery, one where temperatures, radiation, and chemical gradients were unlike our own. The interstellar traveler has reminded scientists of a humbling truth. Our solar system is not the template, but a single variation among countless possibilities. In its silence and restraint, Atlas has given us a glimpse into how different planetary systems might evolve, and by extension, how diverse the galaxy's chemistry of life might be. For the public, the fading sky feels melancholic. Where once people gathered nightly to watch multiple tails gleam against constellations, now the heavens are quieter. Headlines shift away, social media threads dwindle, yet the imprint of wonder remains. Those who saw the cluster will carry it as memory, telling future generations, "I was alive when the sky was full of comets." Just as ancient chronicles recorded celestial visitations, so too will ours, though written in digital archives and photographs rather than parchment. Culturally, the comets of 2025 have already transcended astronomy. They have been woven into music, art, literature. Some frame them as symbols of fragility, others as harbingers of resilience. Atlas, in particular, has become metaphor. The stranger who arrived quietly, witnessed the chorus, and departed without drama. Its aloofness has inspired as much imagination as the flamboyance of the seven natives. It is a reminder that silence can be as powerful as spectacle. In scientific circles, debates continue. Was the cluster purely statistical, a coincidence magnified by solar maximum and modern detection methods? Or was it the delayed echo of ancient perturbations? A passing star, a galactic tide, a subtle resonance? No consensus has yet emerged. But the lack of certainty is itself productive. It keeps inquiry alive. It ensures that future models will be sharper, simulations broader, telescopes more ambitious. The comets have not given final answers, but they have posed better questions. And that, perhaps, is their legacy. Comets are fleeting, but the questions they inspire endure. They remind us that the universe is not fixed, but dynamic, not fully known, but endlessly unfolding. They show us that meaning is not given by the cosmos, but created by us, in the act of observing, recording, and wondering. As Atlas disappears into the black, as the seven natives fade into dormancy or disintegration, the skies return to quiet. But in that quiet lies memory, and in that memory lies continuity. The year 2025 will be remembered not only for what was seen, but for what was learned and for what remains to be asked. By early 2026, the cluster has passed fully into history. The skies are quiet again. The bright arcs that once unsettled and inspired have dissolved into faint whispers of dust, indistinguishable from the starry background. For casual observers, the spectacle is over. But for scientists, it lives on, in archives, in simulations, in theories that now stretch forward for years to come. The first major lessons concern fragility. Of the 7 native comets, 3 fragmented dramatically, leaving trails of debris that will slowly disperse into meteoroid streams. One of those streams is projected to intersect Earth's orbit centuries from now, promising a future meteor shower that our descendants may watch. Others survived, but altered. Rotation states shifted, surfaces stripped, nuclei weakened. Each outcome adds to a growing catalog of cometary life cycles, teaching us that comets are not stable relics, but evolving, fragile bodies that record time through their destruction. 3I Atlas, by contrast, did not fragment, did not flare, did not indulge human expectation. Its survival has now become its most important feature. In a cosmos where fragility is the rule, endurance stands out. Its chemistry, its dark crust, its faint tail, all suggest that interstellar comets are hardened in ways native comets are not. To study Atlas is to glimpse resilience in matter, endurance across light years. That contrast between fragility and endurance has become the central theme of 2025. The scientific debates sharpen. Was the cluster purely a matter of probability? Some argue yes, pointing to simulations that show rare but possible bursts of arrivals. Others argue no, suggesting the influence of galactic tides or a long-past stellar encounter. Both camps agree that models must expand. The Oort cloud, vast and unseen, cannot be treated as uniform any longer. Its architecture may hold echoes of encounters we have not yet identified. To explain 2025 may require thinking not in centuries, but in millions of years. Culturally, the event continues to reverberate. Books and films already reinterpret the cluster as symbol. Some present it as a warning, others as a celebration of cosmic beauty. Atlas, in particular, has been cast as metaphor, the alien observer, the silent traveler, the uninvited guest. Its aloofness has captured imagination, becoming the focus of myths and speculations beyond science. In a sense, Atlas has transcended astronomy, becoming a character in humanity's collective narrative. For the public, what remains is memory. Families recall nights spent watching comets together. Amateur astronomers recall staying awake to capture faint tails with modest telescopes. Children recall learning that the sky is not static, but alive. These personal memories are the true legacy, moments when the cosmos felt intimate, when wonder was direct rather than abstract. And yet, even in memory, the mystery persists. People ask, why now? Why so many? Why coinciding with solar maximum, and why in the same year as an interstellar visitor? Science offers answers, but never final ones. Chance is sufficient, but unsatisfying. Perturbations are plausible, but unproven. And perhaps that is why the cluster endures in imagination, because it straddles the line between explanation and enigma. For astronomers, the work continues. Data from 2025 are now a foundation for new missions. Proposals circulate for rapid response spacecraft designed to intercept interstellar objects within months of detection. Instruments are refined to capture faint signatures of organics. Models are expanded to simulate not just solar system dynamics, but galactic influences. The comets of 2025 may be gone, but they have set science on a new trajectory. The sky above is quiet again. Stars burn steadily. Planets trace predictable paths. But those who remember 2025 know that the quiet is temporary. Somewhere in the Oort cloud, new wanderers are already inbound. Somewhere beyond, interstellar travelers are crossing gulfs toward us. The universe does not repeat itself, but it does rhyme. And one day, another convergence will come, different in detail, similar in wonder. Until then, 2025 remains a reminder that the universe is not static, but alive, not silent, but speaking through ice and dust, not empty, but crowded with meaning, if only we choose to listen. As the first analyses of 2025's cometary data circulate, patterns emerge that are as unsettling as they are illuminating. The cluster, though officially explained as coincidence amplified by solar maximum, refuses to feel entirely random. Even the most cautious researchers admit the timing is uncanny. 7 comets blazing in 1 year, each responding differently to solar storms, while an interstellar visitor drifts among them. It is a tableau so unlikely that it forces reflection not only on physics, but on probability itself. Probability, after all, is a language of perspective. To say that the cluster is a 1 in 10,000 event is to acknowledge rarity, but also inevitability. Given enough time, the improbable becomes certain. Somewhere, sometime, 7 comets must gather. We just happen to be alive to see it. Yet the human mind struggles with this logic. We live short lives, we crave patterns, and we resist the idea that meaning is absent. The comets, in their brilliance, feel designed, even if they are not. This resistance has fueled competing narratives. Some frame the cluster as echo, a delayed consequence of an ancient stellar flyby that disturbed the Oort cloud. Others describe it as resonance, galactic tides aligning orbits in ways we have yet to model. Still others dismiss it as pure chance. Each explanation has merit, none complete. What unites them is the recognition that the Oort cloud, vast and unseen, is more dynamic than we once imagined. The comets of 2025 are its emissaries, fragments of a reservoir we barely understand. The data sharpen this picture. High-resolution spectra reveal subtle isotopic ratios, hinting at varied birthplaces within the early solar system. Dust grains captured in the stratosphere show crystalline structures mixed with amorphous ones, confirming a chaotic history of scattering and migration. Each comet is a shard of a puzzle larger than any single orbit. Together, they suggest that the Oort cloud is not a silent shell, but a living archive, shaped by encounters across cosmic time. 3I Atlas remains the wild card. Its chemistry diverges, its surface endures, its behavior defies expectation. It has become a symbol of alienness, not theatrical like the 7 natives, but quietly insistent. Scientists note its muted outgassing, its dark crust, its faint tail. To some, this restraint is disappointing. To others, it is revelation. Atlas is proof that planetary systems are not interchangeable. Its silence is not absence of story, but presence of another, written under a different star. Culturally, Atlas has already been mythologized. It appears in novels as the silent witness, in poetry as the stone among flames. Its endurance, contrasted with the natives' fragility, has become metaphor. Resilience versus transience, alien stoicism versus local brilliance. Humanity has cast meaning onto it, as we always do with the sky. And perhaps that meaning, while not scientific, is no less real. The fading of the cluster also leaves a new kind of quiet, one not of absence, but of reflection. People who watched the skies in 2025 now look upward differently. They know the heavens are not immutable. They know chance can bring spectacles as rare as this. For many, it is the first time the cosmos has felt personal, a reminder that we live in a dynamic system, not a static dome. For scientists, the reflection is sharper. The year has exposed gaps in models, uncertainties in dynamics, fragility in assumptions. It has reminded us that even after centuries of study, the solar system retains surprises. That humbling is itself valuable. Science advances not through answers alone, but through questions sharpened by anomalies. The legacy of 2025, then, may not be its explanations, but its provocations. It has provoked wonder in the public, urgency in researchers, and humility in all. The comets have come and gone. Atlas has slipped back toward the dark. But the questions remain, burning longer than tails of dust, lingering like after-images in the collective imagination. And perhaps that is the truest message of the cluster, that the universe does not need to design meaning. It only needs to exist. We supply the meaning ourselves in the act of watching, wondering, and remembering. The fading of the 2025 comets does not mean the fading of their influence. If anything, their disappearance has made them more powerful. The spectacle is now memory, and memory sharpens meaning. What was once observed in real time is now reinterpreted, debated, transformed into story. Already, the comets are slipping from data into myth. In universities, seminars parse orbital dynamics, modeling whether the clustering could indeed be random. Some simulations suggest that bursts of comets may be more common than thought, their rarity exaggerated by the brevity of human observation. Others maintain that the odds remain long, pointing to unseen influences still to be uncovered. The tension between chance and causation continues, unresolved. In laboratories, grains of comet dust are studied under microscopes. Some contain complex organics, fragile molecules that may have played roles in life's emergence. Others contain isotopic ratios that defy expectations, suggesting birthplaces far from the regions we thought possible. Each discovery fuels both science and speculation. If comets can carry the ingredients of life, then perhaps life itself is less improbable than we once feared. Atlas, too, remains a subject of fascination. Though it is now receding into darkness, the data it left behind continue to challenge assumptions. Its chemistry is not only alien, but internally consistent, implying that it truly belongs to another system rather than being an outlier of ours. Its faintness, once frustrating, has become clue. Perhaps most interstellar comets are like this, dark, quiet, overlooked. If so, then Atlas is not exception, but archetype, the first of many silent wanderers we will one day detect. Beyond science, the cultural resonance grows. Writers describe 2025 as the year the sky spoke. Musicians release albums inspired by the chorus of seven. Filmmakers begin projects that dramatize the convergence. Even religions absorb the event, some interpreting the comets as signs of endings, others as symbols of renewal. The sky, impartial and indifferent, has been drafted into human narratives once again. Yet beneath the layers of myth, the fundamental lesson remains scientific. The universe is more dynamic than we imagine, more chaotic, more interconnected. The comets of 2025 remind us that the solar system is not a stable clockwork, but a living system shaped by forces beyond our immediate sight. Galactic tides, passing stars, interstellar debris. We are not separate from these forces, but part of them, passengers in a cosmos too vast to fully chart. This realization sparks new ambition. Proposals emerge for rapid response missions capable of intercepting the next interstellar visitor. Others suggest building survey telescopes dedicated to scanning for faint wanderers. The logic is clear. 2025 has shown us what is possible, and we cannot afford to be unprepared for the next opportunity. Meanwhile, ordinary people continue to share their memories. Social media threads compile photographs of comet tails stretching across city skies, rural horizons, desert nights. Amateur astronomers post notes about sleepless vigils, nights when the cold air bit their hands, but the sky rewarded them with visions of beauty. Families recall watching together, children gasping as tails appeared above the horizon. These stories are not less important than the data. They are the human record, proof that wonder still binds us to the heavens. And so, even as the comets fade, their influence grows. They have left traces in science, in culture, in memory. They have reminded us that the sky is not static, that the universe is not finished, that meaning is not given, but made. Perhaps that is the truest legacy of 21.5. Not the comets themselves, which will vanish, not the data alone, which will be analyzed, but the synthesis of both, the way fleeting light inspired enduring thought. The comets will not return, but their questions will. And in the end, questions are more lasting than fire in the sky. As winter approaches, the echoes of 2025 grow louder in reflection than in the sky itself. The comets that once commanded attention are now nearly gone, faint smudges fading into obscurity. Yet their absence has only sharpened the impression they left behind. What was fleeting has become lasting, because it was rare and because it was shared. In the halls of science, the work continues with quiet intensity. Data streams from dozens of observatories are being consolidated, producing a collective record more detailed than any cometary year in history. Teams debate interpretations late into the night. Was the clustering a coincidence? Did a stellar flyby millions of years ago set it in motion? Are we simply witnessing the natural variability of a reservoir too vast to model completely? Each possibility is discussed, none discarded. The absence of certainty is itself productive. It reminds science that humility is not weakness, but strength. For those studying planetary origins, the comets provide a bounty. The diversity revealed in their chemistry is striking. Some carry volatile rich ices that suggest formation in the outermost zones. Others contain high-temperature silicates that must have formed near the proto-sun before being flung outward. Together, they confirm that the Oort cloud is not just a distant shell, but a museum of migration, an archive of scattering events that span billions of years. And then there is 3I Atlas. Its data continues to provoke. Comparisons with the 7 natives highlight not only its alien chemistry, but its alien behavior, its muted response to solar heating, its quiet endurance under storms. For some researchers, Atlas has become more than a curiosity. It is a prototype of a new class of objects, interstellar archives, carrying stories not of our sun, but of others. Each such visitor is a messenger of diversity, proof that the galaxy is not homogeneous, but a patchwork of histories. For the public, the fading of the cluster has not erased its emotional impact. People who once gathered to watch the skies now gather to remember. Communities organize exhibitions of amateur photographs. Documentaries air, weaving science with human testimony. The year is already entering folklore. Children hear stories of the year the sky was crowded, and for them, it becomes a legend, even if they were too young to see it themselves. In this way, the comets extend their lives, not through tales of dust, but through memory. Culturally, Atlas has taken on a role larger than science alone. It is portrayed as the stranger, the outsider, the one who arrived quietly while chaos flared around it. In poetry, it is the symbol of endurance. In fiction, it becomes the visitor who refuses to explain itself. In philosophy, it is cited as a reminder of the alienness of the universe, of how much lies beyond our grasp. No matter how scientists insist on caution, the human imagination insists on story. Perhaps this is inevitable. The cosmos does not communicate meaning, it only acts. But humans cannot help but read action as message. We have always done so. Comets once warned of kings' deaths. Now they inspire science fiction and philosophy. The interpretations have changed, but the instinct remains. It is not superstition, but human nature, to make story from light. And so, as the comets fade, what remains is less spectacle than synthesis. Science gains data, culture gains symbols, memory gains moments. Each domain is valid. Each, in its way, ensures that 2025 will not be forgotten. The cluster is over. Atlas has departed. The sky has returned to quiet. But the silence is not emptiness. It is filled with the afterglow of questions, with the resonance of wonder, with the recognition that even fleeting phenomena can alter how we see the universe. Perhaps that is the final gift of 2025, a reminder that our lives, like comets, are brief, but that brevity does not diminish significance. It enhances it. By the time 2026 begins, the cluster of 2025 is no longer a spectacle of the sky, but a story of the mind. The comets themselves are gone, dimmed, fragmented, receded into the black. 3I Atlas has vanished toward interstellar night, its faint glow swallowed by distance. What remains is not their light, but their legacy. The questions they forced us to ask, the symbols they became, the wonder they rekindled. Scientists convene conferences dedicated entirely to the cluster. Panels dissect every fragment, every orbit, every anomalous ratio. Data are compared across nations, instruments, and wavelengths. Already, papers fill journals, one arguing for statistical coincidence, another for echoes of a past stellar flyby, another for subtle resonances driven by galactic tides. Consensus remains elusive, but the diversity of explanations reflects the richness of the mystery. Where certainty falters, science thrives in debate. The cometary chemistry, too, has left its mark. The variety revealed is staggering. Some comets carried high concentrations of carbon chains, others nitrogen-rich compounds, still others silicates that require temperatures far higher than the outer nebula could provide. Together, they confirm a solar system born not in calm, but in chaos. Materials from different regions mixed violently, then scattered outward. The Oort cloud is not a uniform reservoir, but a scrapyard of the early sun's upheaval. Each comet is a shard of that violence, preserved until chance sends it inward. Atlas has proven equally transformative. Its alien chemistry has become a reference point, a data set that future interstellar visitors will be measured against. Its muted behavior is now seen as characteristic, not anomalous, suggesting that most interstellar objects may look more like Atlas than like the flamboyant Oumuamua or Borisov before it. This realization reframes expectations. The galaxy may be filled with such quiet travelers, slipping through unnoticed because we are not yet watching closely enough. For the public, the comets remain alive in memory. Schools hold comet nights, revisiting photographs from the year before. Amateur astronomers publish compilations of their observations, small telescopes pointed at a sky that, for once, offered something extraordinary. Artists continue to reinterpret the event, from paintings of 7 blazing tails to minimalist sculptures of Atlas alone. The story has become part of cultural fabric, one more reminder that the heavens are not distant abstractions, but immediate, visible, shared. And yet, even amid celebration, unease lingers. The sense of coincidence is not easily dismissed. People ask, will it happen again? Was it truly chance? Was Atlas part of something larger, or only a solitary messenger? The absence of final answers ensures the event remains fertile ground for speculation. The boundary between science and story is porous, and the cluster lives on in both. Perhaps that is the truest lesson. The comets have shown us that the universe is not obligated to explain itself. It presents phenomena, not interpretations. Meaning is ours to construct. And in constructing it, we reveal as much about ourselves as about the cosmos. The cluster is a mirror of science's humility, of culture's creativity, of humanity's need for story. The sky above is quiet now. Stars shine steadily, planets wander predictably. But for those who witnessed 2025, quiet no longer feels like absence. It feels like anticipation. Somewhere, another convergence awaits. Somewhere, the improbable is preparing to unfold again. The universe will surprise us, not because it owes us wonder, but because wonder is inevitable when chance and time converge. And when it does, we will remember 2025, not as anomaly, not as omen, but as precedent. A reminder that sometimes the sky gathers itself into spectacle, and that to be alive in such a moment is its own form of fortune. As the memory of 2025 settles into history, scientists begin to realize just how much the year has shifted the trajectory of their field. The cometary cluster was not simply an anomaly to be explained, it was a turning point. It has forced a reassessment of models, inspired new missions, and reawakened public fascination with the cosmos. In its aftermath, astronomy feels both humbled and energized. One of the clearest outcomes is a surge in planetary defense research. The fragmentation events of 2025, though harmless, underscored the unpredictability of cometary bodies. Some flared into brilliance, others shattered without warning. For scientists tasked with protecting Earth, this was a sobering reminder. What if such a breakup occurred in a comet on a collision course with Earth? Would fragments multiply the threat or mitigate it? Would predictions fail? These questions are no longer theoretical, they demand answers. And so the cluster has fueled urgency in developing tools to track, model, and, if necessary, deflect such objects. Another outcome is the expansion of interstellar research. 3I Atlas, though subdued in spectacle, was revolutionary in implication. It reminded us that our solar system is porous, that material from other stars passes through routinely, unseen until now. Its muted activity suggests that most interstellar comets may not announce themselves with brilliance. Detecting them will require vigilance, sensitivity, and rapid response. Proposals for new wide-field telescopes are already gaining momentum, designed to catch faint wanderers before they slip away. The cultural legacy is equally strong. The year of comets has entered the lexicon, joining Halley's and Hale-Bopp as touchstones of collective memory. People speak of it not just as an astronomical event, but as a shared human experience. Do you remember 2025 has become shorthand for wonder? And in that wonder lies a bridge between science and society, proof that the heavens can still unite us in awe. Yet the deepest legacy may be philosophical. The cluster has reminded us that the universe is not orderly in ways we expect. It is not clockwork precision, but layered chance and chaos. To see 7 comets converge and an interstellar visitor pass among them is to glimpse how vast probabilities, stretched over time, can mimic design. It is a lesson in humility that our desire for meaning does not obligate the cosmos to provide it. And yet, paradoxically, the absence of inherent meaning has not lessened the wonder. It has magnified it. In scientific circles, a phrase has emerged, the resonance of coincidence. It captures the idea that improbable alignments, though natural, still carry weight. They remind us of how rare our perspective is, how fleeting our chance to witness certain phenomena. In 2025, the resonance of coincidence gave us a sky alive with fire. It may not have been designed for us, but we were here to see it. That fact alone is extraordinary. As Atlas fades further into the black, its role grows rather than diminishes. It has become a benchmark, a symbol, a reminder that our solar system is one among many. Its silence, its restraint, its refusal to play into spectacle, all of it speaks not in drama, but in endurance. Where the native comets burned brightly and died, Atlas survived and departed. Both stories are valuable. Both remind us that the universe tells its truths in more than one voice. And so, as the chapter of 2025 closes, what remains is not loss, but legacy. Legacy of science advanced, culture enriched, humility deepened. The comets will not return. Atlas will never return. But the questions they raised, the awe they inspired, the sense of connection they forged, those will endure. The sky is quiet again, but for those who remember, quiet no longer means empty. It means waiting. By now, with the skies emptied of comets, humanity has entered the stage of retrospection. The comets of 2025 are no longer active events, but enduring questions, woven into scientific discourse and cultural memory alike. What was fleeting in appearance has become permanent in impact. The convergence has passed, but its resonance continues to unfold. In research centers, the focus has shifted toward synthesis. Teams compile databases that cross-reference every observation, spectra, light curves, fragment trajectories, dust composition. The goal is to build a comprehensive picture of what the cluster revealed about cometary diversity. Already, early conclusions are being drawn that comets are more varied than we imagined, that their lifespans are shorter, that their fates diverge in ways no single model can capture. The lesson is that comets are not anomalies, but archives, each one preserving a different page of the solar system's chaotic infancy. Atlas, meanwhile, has become a touchstone. Its silence, its endurance, its alien chemistry are now reference points for interstellar research. Some scientists describe it as the control group of the cosmos, the outlier that reveals what is unique about our own system by refusing to conform. Others argue it is not an outlier at all, but the archetype, that interstellar comets are generally quiet, dark, and easily overlooked, and that Borisov was the rare exception. If this is true, then Atlas has shown us how limited our sampling is and how much more lies beyond detection. Beyond science, the comets have transformed culture. The year has become an emblem of awe, inspiring not only art, but perspective. People speak of 2025 as the year they remembered the sky. In a world of distractions, the heavens broke through, demanding attention. Families gathered outdoors, strangers shared telescopes, and millions realized that the cosmos is not abstraction, but reality. That shared memory may prove as important as the data itself. The philosophical impact is subtler, but no less profound. The cluster has reminded us that coincidence and meaning are not opposites. Coincidence can feel meaningful because of how it intersects with human lives. 7 comets and an interstellar traveler did not arrive for us, but we were here to see them. The resonance lies not in design, but in simultaneity. In the unlikely overlap of cosmic and human timelines, this too is a kind of significance, even if it is not intentional. Scientists emphasize humility. The Oort cloud remains a mystery, the galactic tides poorly understood, stellar encounters only partially mapped. Our models are improving, but they remain approximations. The cluster is a reminder that the universe still surprises us, that knowledge is provisional, and that certainty is always temporary. For a field devoted to discovery, this humility is not defeat, but invitation. And for the public, the invitation has been accepted. Enrollment in astronomy courses surges. Telescope sales spike. Interest in planetary defense grows. The year has not only provided spectacle, it has recruited curiosity. In this sense, the comets continue to act as messengers, not of doom, but of inspiration. Perhaps that is their greatest gift. Not the fragments they left, not the data they produced, but the perspective they restored. A reminder that we are part of a system vast beyond measure, fragile yet resilient, transient yet enduring. A reminder that to look up is to see both the past, written in ice, and the future, written in questions. The skies are quiet again, but humanity is not. The memory of 2025 lives on, in science, in art, in philosophy, in wonder. The comets have gone, but the story continues. By mid-2026, the cometary cluster has become less a recent event and more a historical landmark. It is spoken of in the same breath as Halley's great apparitions, as Shoemaker-Levy's collision with Jupiter, as Oumuamua's sudden arrival. But unlike those singular events, 2025 was multiplicity, a chorus, a convergence, a spectacle that resisted reduction to one narrative. Its uniqueness is not just in what happened, but in how much happened at once. Scientists now describe the year as a natural laboratory. For the first time, multiple comets were observed under nearly identical conditions. The same solar cycle, the same heliocentric distances, the same space weather events. Comparing their responses revealed a diversity previously hidden by time. Some brightened spectacularly, others remained faint. Some fragmented, others endured. Each comet became a case study in resilience versus fragility, individuality versus generality. The data continued to surprise. One comet showed an unexpected surge of heavy noble gases, suggesting it trapped volatile elements under pressures and temperatures not thought possible for its size. Another contained nanodiamonds, formed only under high-energy conditions. These findings complicate models of cometary formation, hinting that the early solar system was more violent, more variable than previously imagined. The Oort cloud, rather than being a homogeneous shell, emerges as a kaleidoscope of stories. And then there is Atlas. Though gone, it remains central. Papers dissect its spectrum, its faint tail, its unusual isotopic ratios. Each analysis confirms what astronomers suspected, that Atlas is not like our comets. It is darker, tougher, chemically distinct. It embodies the reality that interstellar space is not empty, but filled with fragments of other suns, each carrying a different story, each an archive of a world we will never see. To study Atlas is to eavesdrop on another star's history. The cultural aftershocks continue. Museums curate exhibits where visitors walk beneath projected comet tails stretching across ceilings. Composers write symphonies that mimic the crescendos of flares and the quiet persistence of Atlas. Novels and films transpose the convergence into allegory, sometimes as warning, sometimes as wonder. Once again, the cosmos has crossed into culture, reminding us that the boundary between science and story is porous, that meaning is made as much by imagination as by measurement. Yet perhaps the most profound legacy is personal. For millions, 2025 was the year they felt the universe directly. Parents still recall taking their children outside at night to watch luminous arcs above the horizon. Amateur astronomers speak of sleepless weeks, waiting for clear skies to photograph tails stretching through constellations. Teachers remember students asking if the comets were talking to each other. These memories will outlive the data, carried forward as testimony that the sky is alive. Philosophers note another legacy, the reconciliation of chance and meaning. The cluster was improbable, yet it happened. Its timing was coincidental, yet it felt intentional. Humans cannot help but bridge that gap, to assign meaning even when none exists. This is not error, but essence. We make meaning because the universe does not. And in that act, we create significance. The skies now are quiet again, but quiet no longer feels like absence. It feels like intermission, a pause before the next performance. Somewhere in the Oort cloud, other comets are on their way. Somewhere in interstellar space, another visitor approaches. We may not know when or how, but 2025 has taught us to expect the unexpected. And so, the legacy of the cluster is not just knowledge or culture, but vigilance. We look up differently now. We watch more carefully. We wonder more deeply. The comets are gone, but the questions remain. And in science, questions are the longest-lasting gifts of all. The story of the comets of 2025 does not end with their fading. It ends with us, with the way we choose to remember, to interpret, to act upon what we witnessed. For the comets themselves, their roles are over. They have sublimated, fragmented, and receded into silence. 3I Atlas has slipped into the infinite, its faint signature swallowed by interstellar dark. But the legacy of that year remains, written not in the sky, but in our memory, our science, our imagination. For astronomy, 2025 was a threshold. It exposed gaps in our models, challenged our assumptions, and expanded our vision of what is possible. The data will be studied for decades, shaping how we understand comets, interstellar visitors, and the chaotic history of our solar system. Already, new missions are in planning. Rapid interceptors, advanced survey telescopes, instruments designed to catch the next visitor before it vanishes. The cluster has accelerated not only discovery, but ambition. It has reminded us that the cosmos does not wait for us, and that vigilance is as important as wonder. For culture, 2025 was revelation. It proved that even in an age of distraction, the sky can still capture collective imagination. Families, strangers, entire communities turned outward, rediscovering a connection to the cosmos older than civilization itself. The comets inspired art, music, stories, philosophy. They became symbols of fragility and endurance, of coincidence and meaning, of transience and permanence. They reminded us that the heavens are not just objects of study, but mirrors of ourselves. For humanity, 2025 was perspective. It showed us that we live not in isolation, but in a system alive with wanderers, stirred by forces far beyond our control. It reminded us that we are passengers in a galaxy of flux, that chance and time can align in ways that feel designed, even when they are not. And it revealed once again that significance is not given by the universe, but made by us in the act of witnessing. The 7 comets blazed and faded. Atlas arrived and departed, but their light lives on, in data that will refine science, in memories that will inspire generations, in symbols that will shape culture. Their legacy is not their presence, but their absence. Proof that even fleeting fire can leave enduring questions, that even silence can speak. And so, the year 2025 will be remembered not as anomaly or omen, but as gift. A gift of wonder, of humility, of perspective. A reminder that the cosmos is not a distant abstraction, but an immediate reality, unfolding above us whether we notice or not. We noticed, and in noticing, we were changed. Now the sky is quiet again, but quiet is not emptiness. It is possibility. Somewhere, another comet has already begun its long fall inward. Somewhere, another interstellar traveler is drifting toward us, unseen. One day, the heavens will gather themselves again into spectacle. One day, chance will align once more, and the improbable will become real. When that day comes, we will remember 2025. We will remember that the universe is alive, that coincidence has resonance, that to look up is to be reminded of both our smallness and our significance. The comets are gone, but the story is not.